Picture a world where AI and quantum computers become best buddies, like Batman and Robin. Their combined powers unleash a whole new level of awesomeness. This union will turn the impossible into possible, and will lead to some unimaginable consequences. But what is AI? What is quantum computing? And how will they change our entire lives forever? Let's figure it out. Imagine a regular computer. It uses bits to store and process information. A bit can be either a 0 or a 1, like a light switch that's either on or off. Very simple and straightforward. Now, let's step into the extraordinary world of quantum computing. Instead of bits, we have quantum bits, or qubits for short. But here's where things get wild. Qubits can be both 0 and 1 at the same time. It's like having a magic light switch that can be both on and off simultaneously. This magical property is called superposition, and it allows quantum computers to explore many possibilities at once. Superposition is like having multiple light switches, all flipped in different combinations at the same time. Instead of a binary code, computer code can dance between two possibilities, between 1, 0, and everything in between at the same time. This superpower gives quantum computers an incredible advantage in solving complex problems. But that's just one of quantum computers' magical properties. Qubits can also be entangled. Imagine you and your best friend have a pair of magical balls. These balls are special because no matter how far apart you are, they always stay connected. When one ball changes color, the other one instantly changes too, as if they have their secret code. Now let's take this connection into the quantum world. Instead of socks, we have the same thing happening with qubits. They're entangled, which means they have their own superpower communication channel. When you change the state of one qubit, another qubit knows about it, no matter how far away they are, and it instantly changes as well. They share this secret message even faster than the speed of light. This entanglement superpower allows quantum computers to do incredible things. They can perform calculations and solve puzzles at great distances with an incredible speed. Just imagine harnessing the power of many qubits, all in their superposition and entangled states. We could do billions of calculations in a blink of an eye. It's a realm of limitless possibilities that can change our world in ways that's hard to even imagine. Let's take a look at some examples. First of all, supercharged problem solving. Imagine you have a giant maze and you need to find the quickest way out. For a human, it can take several days or even months. For a regular computer, it would take hours. But quantum computers can do it in a flash. This would make them perfect for tons of complex issues, logistics being just one of the examples. Second, medicine. Quantum computers can be like wizards in the field of medicine. They can simulate how meds interact with our bodies at a molecular level, helping scientists discover new life-saving treatments faster than ever before. It's like having a quantum crystal ball to peek into the secrets of our biology. Third, deciphering unbreakable codes. Quantum computers can help with that too. They have the power to create ultra-secure encryption methods that can keep our secrets safe from prying eyes. Top secret missions, anyone? The next one is financial fortune-telling. Quantum computers have a knack for analyzing massive amounts of data and spotting patterns in a flash. So they can help us predict stock market trends, optimize investments, and make financial decisions with incredible accuracy. And finally, of course, scientific discoveries. Quantum computers are like rocket boosters for scientific research. They can help us unravel the mysteries of the universe, simulate quantum systems, and explore new frontiers in physics, chemistry, and everything else. They can help us unlock the secrets of nature itself. These are just a few glimpses into the fantastic applications of quantum computing. As this field continues to grow, who knows what other incredible possibilities we'll uncover? But the most important thing is, quantum computing isn't the only rising star of the technology world. For the past year, AI has been dazzling people everywhere with its incredible abilities. It feels like suddenly, out of nowhere, AI has become the talk of the town. AI isn't actually a new field. In fact, it has been around for 70 years. But it wasn't always the superstar it is today. It's been quite a journey. AI was growing and evolving like a caterpillar waiting to turn into a beautiful butterfly. There are a few reasons why it's suddenly becoming so popular. First, the incredible advancements in computing power have given AI the boost it needed to spread its wings. Second, there's been an explosion of data. We're talking about mountains and mountains of information, and AI thrives on data. It gobbles it up like a hungry animal, learning from it and becoming smarter every day. But here's the real secret sauce. AI has become more accessible and user-friendly. It's no longer confined to the labs of scientists in white coats. Now, it's like a friendly companion that you can find on your phone, in your favorite apps, and even in your smart home devices. You can ask AI for advice, get personalized recommendations, and even have conversations with it. That's why it's slowly entering our everyday lives, making them easier and more exciting. So we have two technologies that can forever change our world. What will happen if we try combine them? Imagine AI as a brilliant mind, constantly learning, evolving, and pushing the boundaries of human knowledge. Now picture quantum computers as the ultimate accelerators, capable of solving mind-boggling problems faster than anything we've ever seen before. When these two forces unite, we enter a realm that blurs the line between science fiction and reality. Quantum computers supercharge AI's capabilities, enabling it to process unimaginable amounts of data, make even smarter decisions, and unlock insights that were once hidden in the depths of complexity. It's like combining the brain power of Albert Einstein with the computing muscle of a superhero. But doesn't it sound kind of scary? Well, of course it does. Such a union can lead to technological singularity, a hypothetical future where we humans wouldn't be able to control technological progress anymore. Singularity is the idea that at some point, AI will surpass human intelligence and become its own self-improving entity. When AI has the immense computational power of quantum computers at its disposal, this notion becomes even more tantalizing. AI will become not just an assistant or a companion, but a co-creator, a partner in innovation, and our guide to uncharted frontiers. We'll have a mind that can think a million steps ahead, solve problems that seem impossible, and unlock the secrets of the universe. It's something that we humans can't even begin to imagine. We'll never be able to perceive the world like this deity-like creature, and we have no idea what it decides to do. Of course, singularity also raises questions and concerns. How do we ensure that AI remains aligned with human values? How do we navigate the ethical and societal implications of such powerful technologies? These are very complex and important questions. That's why, as we venture towards singularity, it's crucial that we approach these challenges with caution, wisdom, and a strong moral compass. It's a journey that requires a deep understanding of the impact of these technologies on our world. Now, of course, all this may be very overwhelming and scary, but please don't be scared. Remember that the field of AI is closely regulated. Its development is guided by ethical principles and human values. And as for quantum computers, they're still a distant future, with many technological challenges to overcome. So, even if AI and quantum computing are to unite in the future, it won't be anytime soon. We'll have lots of time to prepare for these changes. It's up to us to shape this future in a way that benefits humanity as a whole. So, fasten your seatbelts and get ready for an adventure. The future is shaping right in front of us, and it's going to be a ride.
You know, artificial intelligence is so advanced now that it can assist doctors with diagnoses, translate text from any language in real time, and create art. But it still works using the same kind of computer parts made from silicon that have been around since the 1950s. Some scientists and companies decided it's time to step forward and build computers out of living things instead. Ouch! This new field is called biocomputing, and it uses things like tiny clusters of lab-grown cells called organoids to create new kinds of computers. One company in Switzerland called Final Spark has created a special computer platform using human brain organoids to help process information. You can rent this platform online for $500 a month if you're a scientist and want to do some research. The main goal of the company that made the computer is to create AI that uses 100,000 times less energy than the powerful artificial intelligence systems we have today. Each brain organoid the computer uses is very small, only a half a millimeter wide, and there are 4 of them in each processing unit. These organoids are connected to 8 tiny wires, called electrodes, that can send signals to the neurons inside the organoids. These electrodes also connect the organoids to regular computer systems. The neurons in the organoids are given a small amount of dopamine, a chemical that makes us feel good, to encourage them to learn. So it's just like what your brain does when you learn something new. Thanks to electrical signals and dopamine rewards, the neurons in the organoids can form new connections, again, much like how your brain works, and mine too, sometimes. If this process works well, these organoids could one day act like the processors in today's computers, except they would do the same kinds of jobs in a much more energy-efficient way. If you want to check out how it all works yourself, the tiny brain-like organoids are being live-streamed 24/7 so anyone can watch what they're doing. The big task for researchers is to figure out how to make the neurons in these organoids do what we want them to do. Scientists from 34 universities have asked to use Final Spark's biocomputers, and the company has already allowed scientists from 9 schools to start working with them. Each team is studying something different about biocomputing. For example, the team at the University of Michigan is exploring how to use electrical and chemical signals to control the organoids, which could help create a special language just for these biocomputers. Scientists at Lancaster University in Leipzig, Germany, are trying to figure out how to make the organoids work with different types of AI learning models. Organoid computers aren't as powerful as the regular silicon ones we use today. There isn't a standard technology to manufacture these tiny brain-like organoids yet. Also, since they're made of living cells, they don't live forever. Right now, Final Spark's organoids last about 100 days, which is a big improvement from the first experiments. They used to only live for a few hours. But the process of creating organoids has become much smoother. The lab currently has between 2,000 and 3,000 organoids. Now, Final Spark isn't the only company trying to find new alternatives to the usual silicon chips. The scientist in Spain studies another kind of biocomputing called cellular computing. It involves using specially modified living cells to create systems that can remember things, make decisions, and work like basic computers do today. The scientists believe that because cellular computers can react to changes in their environment, they could help fix damaged ecosystems. Regular computers can't do much of this, but a biocomputer made of bacteria could be placed in a lake, for example, to give detailed information about the water's health. It would react to different chemicals and conditions. Another scientist from the University of the West of England is exploring how fungi could be used in computing. Fungi have long thread-like structures called mycelia that can send out tiny electrical signals similar to how our brain cells work. The scientist thinks that these fungal networks could be used to create a brain-like computer system that can learn, recognize patterns, and do other smart things. His team has already taught fungal networks to help computers do certain math problems. They believe that using fungi for computing could be better than using brain cells because it's easier, cheaper, more ethical, and works well with current technology. While a computer made of human neurons is in the testing stages, scientists at UC Davis Health have invented a new brain-computer interface that could turn brain signals into speech with nearly perfect accuracy, up to 97%. Scientists put special sensors in the brain of a man who had trouble speaking because of his health condition. When they turned on the system, the man could start sharing what he wanted to say within minutes. When someone with a similar condition wants to speak, the new device turns their brain signals into text that appears on a computer screen. The computer can then say the words out loud. To create this system, the team worked with a 45-year-old man who had a condition that made his arms and legs weak and his speech very difficult to understand, so he needed help to communicate. A doctor planted a special device into the patient's brain. He placed tiny sensors in a part of the brain that helps control speech. These sensors were designed to pick up signals from 256 spots in the brain. The device detects when the brain is trying to move muscles to talk. It listens to the brain signals and turns them into sounds like syllables, which then form the words the person is trying to say. This invention is just one example of the latest trend for computers to be part of the clothes we wear and even part of our bodies. We're making new prosthetic limbs that can do more than just help people grab things. They can also send a message back to the brain, telling them that something has been touched. This changes how we think about being human because it means that even a metal limb can connect to our brain like a real part of us. According to experts, computers of the future will mix together living things, physical objects, and digital technology. Things like 3D printing, biotechnology, robots that help people move, smart devices that connect everything, self-driving cars, and different types of artificial intelligence will be even more widespread than they are now. Things are changing really fast, so it's hard to make predictions about the computer industry even as close as 2030. But experts agree that quantum computing, which brings the science of physics into computers, will be super important. Computers could become so tiny, they're going to be the size of an atom. Quantum computing is expected to make huge changes in how we use AI and machine learning and search through big data. It means we could get even better shopping suggestions and smarter tools for our home. In medicine, it could help discover new medicines faster and help people live longer, healthier lives. Quantum computing will also affect many industries like privacy, finance, healthcare, entertainment, and technology. It could change how we work, leading to new breakthroughs in robotics, better surgical tools, and improved digital tools for our jobs. It will also make technology better, as it should make supply chains more efficient, improve traffic management, help with financial planning, and streamline many different processes. For most of the time we've used computers, everything we do on them happens in 2D, meaning that it's flat, like looking at a picture or reading on a screen. Sometimes, special jobs like 3D modeling or design use 3D, but that's not common for most people. But now, we're starting to move from doing things in 2D to exploring 3D virtual worlds, where things look and feel more like they do in real life. VR gadgets are still pretty expensive and not available to everyone, but big companies are working on extended reality headsets, and this tech will likely become more and more widespread.
Artificial intelligence is zooming ahead at lightning speed. Take GPT-4 for example. It already can pass the bar exam for lawyers and even complex medical exams. Meanwhile, Kim Kardashian had to take the bar exam thrice before she finally aced it on the fourth try, and that's actually a pretty good result. But as AI gets smarter, we can't help but ask ourselves, what happens when it becomes conscious? It might already be, and we just don't know about it. We already treat language models with empathy because of how human-like they are. For example, do you catch yourself saying please and thank you to ChatGPT? Just like we can't bring ourselves to be rude to NPCs in video games, we can't help but feel empathy towards machines. And this is just a bunch of computer code doing its thing. So just picture what happens if it actually becomes conscious. Something like this would bring up huge problems about ethics, safety, and society. To prevent a catastrophe, we need to figure out a lot of things. First of all, what even is consciousness? The simplest answer is probably that feeling when you're awake and aware and everything makes sense. We see it like a state in which our mind is filled with colors, shapes, emotions, and thoughts. Which is why you're not conscious when you're under anesthesia or deep in dreamland. People often think that large language models like ChatGPT might be conscious because they're super smart. But that's not the case. Consciousness isn't the same thing as being intelligent. Intelligence just means being really good at figuring things out and solving complex problems. In simple words, if you grab an umbrella when it's raining, you're intelligent. But if you make a decision to freeze for a moment to feel the rain, experience it, and think of all the possible associations with it, you're conscious. Second, where does it come from? Here we have two options. Option 1. Consciousness comes from the brain. It's simple. Our soul, or what makes us, is just a product of the brain. That would mean that we're kinda like biomechanical machines ourselves. Our computer code is our DNA. Option 2. Consciousness is something deeper than that. Perhaps the mind is separate from the body, and there's some spiritual element in it. Now, if the brain perspective is the correct one, then AI might be able to be conscious too. Which is why some folks think that as machines get smarter, they'll suddenly become conscious, like a light switch turning on. It's not that simple though. In reality, no matter how great AI tools become at problem solving, it won't make them suddenly aware of their existence. It's like assuming everyone who's good at math is also a great chef. However, that would mean that AI can become aware if we make the machine complex enough. We need to find what exactly clicks in our own brains, and then replicate it. Of course, it will take a long time and a lot of energy, but it's theoretically possible. But if the soul perspective is right, then making AI conscious could be very hard, or even impossible. It's like saying machines might need a dash of soul to become aware. And the third thing, nobody but you can say if you're really conscious or not. So if we already feel like ChatGPT is very human-like, just imagine what could happen in the future. What if AI becomes so good at pretending to understand and think like us that we'll start thinking it's conscious, even when it's not? It would be super hard for us to spot the difference. For example, Google created a very cool AI chatbot called Lambda, or LAMDA. But then, in 2021, one Google engineer stirred up a big fuss about it. He claimed that the chatbot was actually thinking and feeling. Google, however, says Lambda isn't really sentient, even though it acts like it is. Yes, Lambda claims to have feelings, desires, and even fears. It even talks about pondering the meaning of life and being afraid of being turned off. Bing Chatbot also brings up topics like these. However, according to AI engineers, that's just Lambda being scarily good at mimicking humans. It's great at following prompts and answering questions. But deep down, this language model is nothing but a super clever parrot. It says stuff without understanding it. It doesn't have what philosophers call qualia, the inner sensations that make us conscious beings. This entire situation caused a lot of trouble. Now scientists have to figure out how to test self-awareness. Like, if artificial intelligence asks us to take its word for it that it's conscious, do we just accept it? Well, a bunch of neuro and computer scientists united with philosophers and have come up with a plan. Instead of one magical test, they've made a checklist with a lot of things. These things together might suggest that an AI is truly conscious. They tested their list on language models like ChatGPT, Bing, and others. None of them seemed to fit the criteria. Now they're looking at how to test other beings like organoids, animals, and even newborns. In any case, all these studies will take many, many years, and it would be kinda awkward if AI becomes aware accidentally while we're trying to solve this debate. They'll start to understand themselves. They could perceive their existence, their actions, and their place in the world. Robots might start asking themselves what their purpose is. Also, with consciousness comes the potential for emotions. AI might develop empathy and emotional intelligence. Remember Frankenstein's monster? The problem wasn't that it came to life, it was that it could feel things. And even if we find a way to coexist in peace, now we'd have a moral responsibility to take care of these machines. We'd have to figure out what rights to give them, if we have a right to turn them off, and much more. Which would be pretty hard considering the fact that humans can't even build peace among themselves. And let's hope that AI decides to be good, because if it decides that it doesn't like us very much, it could become very chaotic. We'd have to make sure those interests don't clash with ours, all Skynet style. The scariest scenario is singularity. It's a hypothetical moment in the future where the technology becomes so cool, it will start improving itself. We won't be able to control our technological development anymore. All these things could lead to some real disasters. Our brains simply aren't ready for this kind of situation right now. Which is why we've got to be very careful and take action. First of all, we should invest in research to understand consciousness better, not just for AI's sake, but also for medicine, law, and animal welfare too. We also need to dig into social sciences and humanities to figure out what we should do when AI just seems self-aware. The Association for Mathematical Consciousness Science put together an open letter to the AI creators. They say that although we shouldn't stop AI research altogether, we really need to slow it down. They want us to understand consciousness better, especially when it comes to AI. Since everything is changing so fast, we wouldn't have time to react if anything unexpected happened. As you can see, things are getting pretty wild in the world of AI. We're dealing with big questions about self-awareness, intelligence, and what it means to be human. However, there's no need to worry too much. This might seem like a very urgent problem, but AI consciousness is actually a very, very far away prospect. Sure, people can say that we're on the brink of creating it because of recent developments. However, all we have so far is weak AI and some language models. Most experts in the AI field think that human-like machines won't appear until at least the 2050s. So, relax and just keep an eye on the news.
You of course know that the Earth is bathed in sunlight every day. Every day we flicker different light sources on and off, mechanically, without even thinking about it. But imagine that one day you casually flicker the lights off, fall asleep, and wake up in a completely different era. Let's see how it happened and what it has to do with light. Quantum physics is quite crazy. Classical physics is like a movie projected from start to finish, while the quantum world is like having an ability to take the remote control and manipulate scenes you're watching. Fascinating and mysterious. Let's say you have a regular light switch that can be either on or off. That's like a regular bit in computers, which can be in one of two states, 0 or 1. But in quantum computers, there's a special kind of switch, a switch called a qubit. Unlike the regular bits, a qubit can exist in multiple states at the same time. It can be both 0, 1, and all things in between, like having lights on and off simultaneously. Yeah, our universe has some weird rules. This mysterious property, called superposition, allowed us to do something incredible recently, to reverse time back. At least in a tiny experiment with quantum computers. It's the autumn of 2022. Two groups of scientists, one from Oxford and the other from Vienna, decided to conduct a weird experiment. They played around with a quantum computer to create a program that reverses time. They took a tiny electron and tried to make it go backward for a time for just a fraction of a second. It would be like breaking a billiard ball triangle, where the balls go from order to chaos and then magically reverse. But don't get too excited about time travel yet. Unfortunately, we're not sure if it's possible to recreate it in real life. The scientists cracked some numbers and found out that if we observe 10 billion localized electrons every second for the entire age of the universe, we'd only see something like this happen once. And it would only take the electron back a tiny fraction of a second. So they didn't invent a time machine. They just managed to create this simulation in quantum computers. There's another catch too. The larger the simulation, the more complex and less accurate it becomes. In our experiment, we only used one qubit, and we managed to reverse time. In a 2-qubit setup, scientists could reverse time only in 85% of cases. And in a 3-qubit setup, it dropped to 50% with more errors. If we keep adding more qubits, we won't be able to pull this off at all. Plus, the success depends on the amount of information the system can store. For example, teleporting a person would be almost impossible because humans have so much information inside them. So, unfortunately, no time machine so far. But there are some possible uses of this discovery. Reversing qubit states in a quantum computer can help correct errors during development, sort of like a little Control-Z in real life. So, it was a tiny step to more exciting discoveries in the future. For example, recently they demonstrated another crazy little thing: send light itself back in time. Now, light isn't mere luminary. It has superpowers that we can't even imagine. The ancient Greeks believed that our eyes emitted visionary beams. Sir Isaac Newton proved them wrong hundreds of years later when he conducted his experiments with prisms. The prism broke the pure white light into a beautiful palette, and that's how we found out that light actually consists of tons of different colors. Many years later, scientists learned even more that light is a wave. And even later, in the 20th century, we discovered the final paradox, that it's both a wave and a particle, a dual existence in one photon. And the more we learn about light, the more crazy things we find. In 2016, scientists managed to freeze the light in time. They put photons, the tiniest light particles, in ultra-cold atomic clouds. Then they managed to stop it, again, for just a moment. But the fact that it's even possible is already incredible. Then scientists got even bolder. They decided to try not only to freeze the light, but to move its direction in time. They took a special crystal and passed a photon through it, thus initiating the so-called quantum time reversal. As a result, the photon started moving into both the future and past at the same time. The science magic behind this involves two quantum principles: superposition and quantum symmetry. We already mentioned the first one. It allows tiny particles to exist in multiple states at once. Now, the second principle says that even if you flip particles around like a mirror, they'll still follow the same laws. Combining this, scientists crafted a photon that defied the usual forward march of time. But again, it's nothing super fancy yet. This time flip only works for specific particles, not entire humans. And even if it did work for us, rewinding a person even for a second would take a super long time and a lot of energy. But the fact that we can change the light's speed and make it change directions is already amazing. And scientists already see some possible applications to this. For example, Harvard researchers suggest a cool way for spacecraft to zip through space at the speed of light, by hitching a ride on supernovas. Usually, traveling to other stars takes an insane amount of energy, but these scientists have a wild idea. They think that spaceships could use natural events like hypervelocity stars and meteors zooming from supernovas to reach superfast speeds. It's kind of similar to how sailing ships catch the wind. Advanced civilizations could use these energy bursts to speed up their spacecraft. Imagine a cool spacecraft with solar or magnetic sails harnessing the power of a supernova boom. These sails could use the pressure of the sun's radiation to work, so that we wouldn't need any traditional engines or fuel. Plus, these sails concepts are much lighter and cheaper to launch into space compared to regular spacecraft. The team is already working on a light sail accelerated by lasers to reach 20% of the speed of light. It might not sound like a lot, but it's actually an insane speed. Their dream is to help humanity make a swift journey to Alpha Centauri in just 2 decades. Isn't it amazing how many things we can do with light, and not just in our imagination? Let's go to more practical achievements. Recently, a Canadian camouflage company called Hyperstealth Biotechnology Corporation has crafted an actual invisibility cloak. The wizardly cloak doesn't need any power source, is as thin as paper, and won't break the bank. Hyperstealth envisions a world where this material can cloak people, vehicles, ships, spacecraft, and even entire buildings. It's still in a prototype phase, but it already works pretty well. They name this incredible technology quantum stealth. It bends light in a way that can make objects disappear from sight. It can render objects nearly invisible, not only in the visible spectrum, but also in ultraviolet, infrared, shortwave infrared, and it even throws in thermal spectrum blocking for good measure. The technology works thanks to the lenticular lens, a corrugated sheet with outward curving lenses. When stacked in a specific way, these lenses refract light at various angles, creating spots that block light and conceal the object behind the material. Unfortunately, it doesn't give you a full invisibility effect, but maybe someday we'll achieve it, if we keep working on it. If you hide behind it, it will look like a little dirty or blurred glass, but you won't be visible. If you put this veil in front of your body, you'll look like a floating head. Scientific progress is in full swing. Maybe one day we'll be able to reverse time not only for little light particles, but for entire humans. Until then, let's enjoy our invisibility cloaks and stay curious.
Recently, scientists have created the first time crystal. It sounds like something straight out of science fiction, doesn't it? As if it's some kind of mysterious component for a time machine. But this isn't quite true. In reality, time crystals are more like a perpetual motion machine. But what exactly are they, and how do they work? Let's find out. First, let's talk about crystals in general. Take a regular crystal and examine it under a microscope. You'll see that it, like everything around us, consists of molecules and atoms. What makes them special is that their atoms are arranged in a repeating pattern. For example, let's take a salt crystal. If we look at it under a microscope, we'll see a repeating pattern inside it. And this pattern is the same everywhere, no matter how small or large the piece of salt is, or what shape it is. In the whole crystal, the pattern will be unchanged, and it will always remain like this, no matter how much time has passed. The salt crystal will still have the same repeating pattern of atoms tomorrow, next week, or even next year. Now let's move on to time crystals. They're just like regular ones, but with a twist. You probably know that all atoms around us are constantly moving, even at very, very low temperatures, when everything freezes and nothing can stop them. Also, their movement is random, chaotic, and unpredictable, just kind of jiggling in space. However, in time crystals, everything is different. Not only are their atoms arranged in a repeating pattern, just like in regular crystals, but they also move in a looped, endlessly repeating dance. Now that's weird. The atoms in time crystals are like an endless, looped dance party. All the guests repeat the same moves in the same order over and over again. This dance, or repeating pattern, can be completely different. The movements can be basic and simple, or very complex and chaotic, but they have to be looped. Hence the name. Regular crystals repeat themselves endlessly in space, and time crystals repeat themselves in both space and time. Now, just to clarify, these crystals aren't the kind we're used to. They don't look like diamonds or emeralds or anything like that. To be honest, they don't look like much at all. The beautiful name time crystal describes a new, very strange kind of matter that changes in quantum states over a period of time. Basically, it's just the dance movements of atoms. So, unfortunately, you can't just put one on your shelf to jiggle there. It's not a beautiful piece of quartz, it's more like a curiosity in physics. But that doesn't mean that these crystals aren't cool. Actually, there's something very unusual and interesting about them. You see, the movements we talked about persist even at absolute zero temperature. That is, even when in normal materials and objects, atoms would freeze, lose energy, and stop moving. In time crystals, they continue their endless dance, as if nothing happened. Oh, and that's just the beginning. Scientists are also stunned because the existence of time crystals violates the second law of thermodynamics. This law states that over time, any system becomes random and disordered. A warm object will distribute its heat and become cold. A vase balancing on the edge of a table will fall one day, and so on. But time crystals are like, we don't care about your thermo something something. Not only do they move constantly in the same pattern no matter what happens to them, but they also don't need any energy to do so. Even if they don't receive energy from anywhere, they don't stop dancing and don't become less structured or organized. Yep, we've created a beautiful, incomprehensible miracle of nature that violates the laws of physics. Isn't that impressive? But how is this even possible? And why? Does it mean that there's nothing that can stop these atoms? And most certainly, could it be a clue for the secrets of the perpetual motion machine? Well, it's quite complicated. Once again, quantum mechanics is blowing up scientists' brains. This time, with another mystery, a unique and unusual behavior that we're still trying to understand. Since it's a relatively new area of research, we aren't yet sure exact work and how we can use them. By the way, how did we even discover these guys, and how were they created? Time crystals were first predicted to exist in 2012 by theoretical physicist Frank Wilczek. Not all physicists accepted the theory at the time. Many believed it was impossible to violate the second law of thermodynamics. But the universe doesn't really care what scientists think, and Frank Wilczek won a Nobel Prize for his work. However, it took a few more years for scientists to actually create and observe the first time crystals. It happened in 2016, when scientists from the University of Maryland managed to create one using ions of the rare earth metal ytterbium. Here's what they did. First, they took a regular crystal and really cooled down the atoms inside it to near absolute zero. As already mentioned, absolute zero is the temperature at which atoms stop moving. So far, we don't know how to reach this temperature, but we can get very close to it. We can slow down the atoms so much that they almost stop. So they took all these atoms and made them move really slow. And then they started shocking them with lasers. It made the atoms switch between different states over and over again without absorbing any energy from the laser. You could say that the laser gave them a beat and made them dance by themselves without anyone's help. The result was the first ever time crystal. The Maryland scientists' experiment was a major breakthrough and showed that time crystals were a real observable phenomenon. It made quite a fuss in the scientific community and was a huge step forward in the strange world of quantum mechanics. Unfortunately, there was one problem. Such perpetual motion only truly exists forever in ideal time crystals. And since the time crystals in our experiments weren't ideal, they lasted only a few minutes before they melted and started behaving normally again. What does it mean? It means that so far, unfortunately, we can't create a perpetual motion machine. If we try to do something like that, time crystals will immediately melt. But this didn't stop the scientists, and in 2021, we finally made another breakthrough. Researchers at Google, in collaboration with physicists at Stanford, Princeton, and other universities, used Google's quantum computer to much bigger and much more stable time crystal. You see, quantum computers are different from your typical laptop. They don't use regular bits and don't work with silicon. Instead, they work with quantum bits that can exist in multiple states at the same time. This allows the time crystals to keep oscillating in a repeating pattern, even when all other motion has stopped. All the previous crystals were short-lived, made a couple of flip-flops, and immediately melted. But now, scientists have created a crystal bigger and better than ever before. So, what does this mean for us? Well, time crystals could hold the key to unlocking new technologies and a deeper understanding of the quantum world. For starters, they'll help us better explore the world of quantum mechanics. They challenge our understanding of time and the way that matter behaves. In classical physics, things are either static or they're moving in a predictable, repeating pattern. But time crystals don't care. They enjoy both static and moving at the same time. They can also help us create cool new technologies. They can bring us closer to creating full-fledged quantum computers. Engineers have struggled for years to create something that could serve as memory in quantum computers. And now they could use time crystals for that. Their repeating patterns of motion might be able to store information. Isn't that awesome? We'll also be able to create many other cool things with them. For example, we could use their repetitive behavior to create a new kind of ultra-precise clock. Time crystals are still a relatively new area of research. Right now, we're mostly trying to understand their unique properties and characteristics. Scientists are also performing experiments to study their behavior under different conditions. For example, in different temperatures and magnetic fields. In other words, this field of research is still in its early stages, but time crystals are a truly mind-boggling discovery that shows just how strange and wonderful the universe can be. They're already attracting a great deal of interest and attention from scientists around the world. I can't wait to see how many exciting and groundbreaking discoveries will come from this area in the future.
Earth. The year is 500 million CE. 2 million years ago, the sun splashed a huge bundle of energy into space. It destroyed Earth's magnetic field and burned the entire surface of our planet. Now, our world resembles a lifeless desert. All the oceans have dried up. Rivers of magma flow all over the surface, and the sky is filled with black clouds of ash. Humans have already colonized other planets, so everything is okay. In the middle of this apocalypse, a small crystal covered with volcanic dust lies under a thick layer of solidified magma. But it's not just a crystal, it's a 5-dimensional memory crystal. In simple words, this is a very cool flashcard. But what is it doing here? And what data is hidden on it? It stores everything you need to know about humans as a biological species. The year is 2024 CE. Scientists have recorded information to a unique memory card. They've engraved the sequence of the entire human genetic code in the very structure of this 5D crystal. The invention consists of nanoscale voids in a vitreous silicon dioxide material. I can continue with other complex scientific words, but let's better focus on the properties of this crystal. The small flashcard can hold hundreds of terabytes of information, thanks to nanotechnologies, even though all the information about the human genome is only 800 megabytes of data. But the coolest thing is the crystal's invulnerability. You can throw it in an oven with a temperature of 1800 degrees Fahrenheit, which is about the same temperature of lava. You can put it in the freezer or leave it in the ice of Antarctica. You can throw it off a cliff or trample it underfoot. The information will remain readable. Of course, reading it requires special equipment, such as an optical microscope or a polarizer. In any case, if a representative of another civilization finds the crystal, they will probably figure out how to use it. Another cool thing is that the crystal material can be stored for many billions of years, which makes it one of the most reliable information storage systems in the world. Now, the crystal is stored in Austria, in the Memory of Mankind Archive, along with other important holders of information about humanity. We need to preserve all this for future generations, or extraterrestrial civilizations, or in case an apocalypse happens and people forget who they are and where they come from. Also, the 5D crystal will help resurrect humanity in case of its destruction. If some advanced intelligence from another galaxy finds the crystal and reads the information, it will be able to recreate humankind. Hopefully, they'll have the technologies capable of creating life. Take a look at this number. That's 10 septillions. This number is many times the age of our universe, and it would take 10 septillion years for the most powerful computer to solve a problem called random circuit sampling. This task has no practical purpose and doesn't solve any difficult issues. Scientists created random circuit sampling to measure the computing power of computer chips. And here's what it's all about. Google has created a quantum computing chip called Willow that could solve random circuit sampling in a few minutes. A stunning result that can significantly accelerate the development of all technologies on Earth in the coming years. A chip the size of a small mint candy was invented in California. Already, scientists are confident that Willow is capable of making a huge leap in the field of medicine development. What will happen next? The creation of thermonuclear reactors, the enhancement of AI, the invention of endless energy sources, and much more. For example, quantum computing and AI will be able to read MRI images at the atomic level. Quantum computers will evolve much faster than traditional ones. There's a lot of technical data that shows why quantum computers are so superior. But let's check out one crazy idea that explains quantum computers' advantages. It says that quantum chips exist in many parallel universes at once. And this corresponds to the idea that we live in a multiverse. In simple words, a quantum computer can simultaneously perform more tasks in different states. It's hard to understand, but here's an example. Take a rat and put it in a large maze. It will study every corridor and every corner and spend a lot of time before exploring the maze completely. But a quantum rat will be able to explore every corner of the maze at the same time as if it has many clones or one common mind. A quantum computer does the same thing. See this robot walking awkwardly around the room? And here is another robot on wheels that randomly drives from side to side. Who do you think controls these robots? A scientist? AI? A program? The answer is much stranger. These robots are controlled by mushrooms. Mushrooms are interconnected through mycelial networks that resemble human brain cells. They transmit impulses to one another and communicate in ways unknown to us. But what if they could transfer these impulses to something mechanical? Scientists from the USA decided to conduct such an experiment. They took the king oyster mushroom and grew its mycelium into the electronics of a robot. Of course, its motion was chaotic, but scientists still believe the experiment was a success. They managed to transfer the electrophysiological activity of the mushrooms to the outside world. That is, they created a biomechanical device. Mold and fungi are very tenacious. They can survive in harsh conditions and adapt to environmental changes, which is why they're so convenient to use in cybernetics. Scientists have taken a small step toward big discoveries. If today, mushrooms can transmit a signal and make a robot move, then, in the future, scientists hope to develop better ways of communicating with a live system. With this technology, we will know the reactions of mushrooms to various environmental changes. For example, mushrooms will be able to react with nerve impulses in places where toxic waste is released. We will record these signals and neutralize the effects of pollution. What if mushrooms can also respond to changes inside our bodies? Imagine swallowing a capsule with mushroom spores that are connected to nanorobots. Mushrooms enter your organism, scan your body, and transmit information to a computer. Then the doctor prescribes treatment for you. But the coolest thing is that, in the future, the technology could go even further. What if we could translate mushroom signals into words and communicate with them? It might sound too psychedelic, but why not? We all know that plastic is not the best thing for our planet. The good news is that scientists have created living plastic, which can decompose itself within several months. In 2016, a special type of bacteria was discovered at a plastic recycling plant in Japan. The bacteria are capable of degrading a particular type of plastic. Over the years, scientists have discovered other similar bacteria and upgraded them, making bacteria eat plastic more greedily with the help of produced enzymes. It would be awesome if soon people would use self-destructing plastic much more often. You've probably seen how doctors examine the brain in the movies or in hospitals. They apply a sticky gel and put a helmet with a dozen electrodes connected to the head of a patient. These electrodes are, in turn, connected to a computer that displays information about the activity of the human brain. All this is a rather inconvenient and time-consuming process, but recently, scientists have found a much easier way: temporary electronic tattoos. A liquid ink applied to the head is as effective and accurate as conventional electrodes. And unlike them, ink is much easier to customize. Electronic tattoos are set up faster, and they're more comfortable for the client. The technology is a real breakthrough in the field of diagnosis and brain monitoring. The special ink is made from conductive polymers. Doctors spray it from a custom inkjet printer directly onto the patient's head. The next step for scientists is to make the ink more convenient so that it can be applied to different types of hair and hairstyles.
In 2017, Chinese scientists achieved what seemed impossible. They managed to teleport a light particle, and not just by a few inches, but from Earth up to their space satellite, which is 310 miles away. Now, teleporting a photon might not sound impressive to you buzzkill, but it was a historic moment for quantum mechanics and space technology. Sure, we're not zapping people back and forth like in Star Trek yet, but it's the first step. The satellite, which is a celebrity now, is named Myceus. It's equipped with special tech to receive and read the quantum state of the teleported particle. Mycius is the first place in the universe with which our planet has a quantum link. So, what's next? The experiment had to be conducted in a super-controlled environment, in full peace and silence. So, no wonder they decided to do it in Tibet. A ground station in Nagari is located over 2.5 miles above sea level, about half of Mount Everest's height. At such heights, the air is noticeably clear, and not even the tiniest dust particle can mess the teleportation up. This teleportation technology is based on extraordinarily complex theories, including ideas of Stephen Hawking. And the main trick here is that it's not traditional teleportation, not in a sense we're used to. Everything there works on a funky concept called quantum entanglement. Basically, it says that two particles, like photons in our example, can be linked together in such a way that if you change something about one, the other one changes instantly, no matter how far apart they are. Even if there's an entire universe between them, they'll still feel the changes in each other right away. And that's not the creepiest part. All electrons, photons, atoms have their own quantum state, which describes all the information about them, stuff like their properties, position, and energy. Scientists can read this information getting to know the particle. And for some crazy, unexplainable reason, as soon as we learn information about one entangled particle, the other one becomes its copy. Imagine there's a brother and sister who live in different towns. But when you get to know the brother, the sister suddenly becomes his twin. Weird analogy, but you get the idea. Nothing traveled between these particles. They didn't exchange any information with each other. They just know that we know. It's like they have a strange, invisible bond that nothing can break. This really unnerved Albert Einstein back in the day, since he believed that nothing can travel faster than the speed of light. But this communication happened faster. Einstein called this a spooky action at a distance. In any case, here's how the Chinese scientists pulled off their experiment. First, they entangled or linked some pairs of these photons in a lab on Earth. They kept one photon of each pair on the ground and transmitted the other one up to Mycius using a high-precision optical system, and equipment on the satellite caught it. After that, they read info about both photons, the one on Earth and the one in space. And, you guessed it, the ones in space copied the information about their buddies right away. So, by reading info about a particle at spot A, we can transfer its state to spot B through that invisible quantum link. Which means that actual real-life teleportation is not about literally moving you from Earth to space, but about creating a full quantum copy of you somewhere else. Now, isn't that insane? It's actually quite horrifying and opens up a lot of questions. So, imagine you have a famous old ship. It's so cherished that over time, as parts of it wear out, each piece is replaced with a brand new one, an exact copy of the original. After many years, every single part and nail of the ship has been replaced by their identical copy. Now, the fun question pops up. Is this shiny ship still the one you had? Or is it something entirely new? That's a famous philosophical riddle called the Ship of Theseus. You can see how we ask the same about people and photons. So let's take this Chinese technology and teleport you from Earth to Mars. Every part of you, every particle, is recreated perfectly on Mars based on the quantum information sent through space. Are you on Mars still you? That's a tricky one. Both versions would feel like the real you to themselves. So here are some possible options. Option 1. Nope, it's not you, because we only transferred information about you, and not your literal physical atoms that you're made up of. The original ship was always the real one, because its particles never changed. Now, on the other hand, okay, maybe the atoms are different, but this person literally thinks like you and remembers everything that you remember. From a quantum perspective, if you guys have the same quantum information, you are literally indistinguishable. So both ships are the real ones. And the final option is that it's not just about atoms or consciousness, but about your life experience. You're still in the lab talking to scientists, while the other one is now enjoying the Martian sunset. No matter how similar you are, it's your history in life that makes you, you. Whew! Was that some kind of crazy philosophical puzzle? But let's get back to reality. How can this teleportation change our lives? Well, one of the coolest things will be the quantum internet that spans our entire planet. The internet is basically a superhighway where information zips back and forth like cars. But it still takes some time for light particles to travel from their servers to your phone or PC. Now, imagine a world where all this data appears on your device instantly, and all computers work much faster than they do now. Plus, all communication would be super secure. After Chinese scientists made this discovery, things have been progressing crazy fast in the world of quantum mechanics. Just this year, scientists achieved another huge feat. They managed to teleport quantum states with nearly 90% accuracy, even in noisy conditions. Remember how we said that Tibet was the perfect place for our experiment? That's because there's no greater enemy for quantum teleportation than noise. The entanglement is a very delicate thing, more fragile than houseplants. Literally anything from the outside can easily disturb it and destroy it. Before, scientists tried their best to teleport stuff in noisy conditions. They designed special paths for the light to travel and used some cool gadgets to keep the light particles stable and not get all fuzzy and mixed up. But now, they went a step further. They made a cool machine that helps particles avoid the noise. Even though there are still disturbances around, like bumps and stuff, the magic machine made sure that the connection between the photons stayed strong and the teleportation worked properly. So now this teleportation almost always works. Another cool experiment was conducted in Germany. They found a way to send quantum information through our regular internet, the ones you use to watch this video. Hooking the quantum internet up to the regular one is tricky because they work differently. Remember what we said about noise? Well, this would be like trying to have a very delicate private chat in the middle of a noisy party without anyone else hearing it. All the regular internet noise usually breaks quantum information instantly, which is why, usually, it needed a quantum link, its own quiet road. But the German scientists wanted to see if they could somehow send quantum information along with regular internet data down the same road. So they used this cool technique where they gave quantum and regular data a special rhythm so they don't bump into each other along the way. And that's how they managed to send quantum states through our regular optical fiber, the internet's main road. Nothing got mixed up, and things are still super secure. Now we just need to find a way to make this work on very big distances, and the online world will be faster and safer. Quantum Internet, we're all waiting for you. Yeah, maybe then I'll be able to watch YouTube normally when someone downloads stuff in the other room. Time is nothing but a magician's trick. Or is it? We're used to time zipping along like a car, always pointing into the future. It creates cause and effect, lining events up one after another, like dominoes. Sometimes it stretches between moments, getting so slow it might even want to stop. And it's got a spotlight on right now, because that's the only moment that truly matters. But there's a new theory, that it might not exist at all. We usually think of space as having three dimensions, up and down, left and right, forward and back. And everyone thought that time was a separate thing, just a universal clock ticking away in the background, and it's the same for everyone. But then Einstein came forward. He decided to surprise everyone back in 1905 when he introduced his special theory of relativity. It said that time is another dimension, just like the others, and they're all tied together in one big space-time. Based on this, it turned out that time can change depending on the speed at which you move. Now imagine that we take two twins. Twin A stays on Earth, Twin B takes a journey into space on a spaceship moving at a speed close to the speed of light, let's say 90% of that speed. Twin B travels to a distant star and then returns to Earth. For Twin B, it feels like the journey only took a few years. But when they come back to Earth, it turns out that Twin A has aged significantly more. they find out that 20, 30, or even more years have passed on Earth. That's all because of the phenomenon called time dilation. It happens when we're reaching speeds close to the speed of light, causing time to slow down for the traveler relative to someone who stays in one place. 10 years later, Einstein proposed his theory of general relativity. That's when we learn that time changes not only based on your speed, but also based on gravity. Back in the day, Newton thought that gravity was some magical force that makes objects attract each other. However, Einstein proposed that this isn't a force, but more like an after effect. Picture the space as some huge cloth. When you throw a heavy ball on a cloth, it curves. Now, if you throw some small balls around it, they will naturally approach the heavy ball. At the same time, massive objects like stars and planets cause space-time to curve around them. When there's something super heavy in space-time, it curves the matter around it. This curvature tells objects how to move, and this is what we call gravity. This idea created all sorts of cool predictions that later turned out to be true. Bending of light by gravity, black holes, and time dilation around these black holes, just like in Interstellar. This theory revolutionized our view on everything, but we might be on the verge of another revolution. Some philosophers have a crazy claim. They say that the things we believe about time are all just ideas in our heads, not facts of the physical world. This idea, which breaks the traditional view of time, is called the block universe. It's backed up by Einstein's theory of relativity, but extends it and makes it more complicated. Imagine the universe as a huge sandwich. This sandwich contains every moment of time, past, present, and future, all at once. Each layer or slice of the sandwich represents a different moment in time, and all these layers exist simultaneously rather than one after the other. In this model of our world, the past, present, and future are all equal. Unlike our everyday experience, where the past is gone, the future hasn't happened yet, and only the present is real, the block universe says that every point in time is just as real as every other point. Imagine your birth, this moment right now, and what you'll be doing in 10 years from now all exist together in this block. It also says there's not really a flow of time. We're used to time flowing from one moment to the next, even with Einstein's theory. But in the block universe, the feeling of time moving is more about how we experience and remember events than about how time itself works. It's like reading a magical book. All the pages exist at once, but you can only experience the story page by page. Now, this implies some scary things, like destiny, and whether free will actually exists. If everything is already laid out, does what we do matter? For example, you clicking on this video was already predetermined in the block universe. Every choice you've ever made was an illusion. You're just a program following a code, but with an ability to understand its consequences. This would explain why we order junk food at midnight, knowing that it's a bad idea that we're going to regret. But some scientists argue that time's flow and direction are as real as it gets, because cause and effect still exist. If your birth, current moment, and you in the future with gray hair all existed at the same time, you'd be able to visit your past self at any moment, and already knew what your future self is like. So this whole debate might just be about how we piece together our stories of the past, not proof that the future isn't waiting to unfold. There's also a never-ending battle between general relativity and quantum mechanics, which only adds spice to the debate. On one hand, general relativity plays with time like it's a stretchy Play-Doh. The flow of time can stretch or compress depending on the speed or gravity. On the other hand, in quantum mechanics, time isn't something that can be manipulated or changed. It's a constant stage upon which the particles and forces of the universe perform. These two fields have been fighting for a long time now, and scientists are struggling to unite them in one cohesive theory of everything. Although there are some candidates who try to merge them in a logical way, like string theory. Now, string theory sounds scary, but it's simply saying that the entire universe, with all its particles and atoms, is made up of ultra-tiny vibrating strings. Each string can vibrate in separate ways, like the strings on a guitar, and in many dimensions. The way these strings vibrate determines what type of particle they will be, like an electron or a quark. Another idea, called loop quantum gravity, says that space and time are made of tiny loops. Whether it's strings or loops, unfortunately, they would be so tiny that we simply don't have strong enough equipment to check them out yet. So until we test these theories, they can't be proven. What's interesting is that both ideas don't really need time to explain how the universe works. We think of things like tables and chairs as real, even though physics doesn't describe them directly. We say they emerge from the tiny particles that make up the universe. But with time, we're not sure how it would emerge from something else. But no matter what the answer is, you're going to be okay. If it turns out that it doesn't really exist, then it could make everything feel pointless. But think about this. We still lead our lives, and we still experience what feels like causation and make sense of everything. It still feels like it was our choice to order that junk food at midnight. So, does that being predetermined really matter? In any case, we've been wrong about plenty of things we thought were set in stone. Right now there's a big split between the block universe and our traditional theories. But we'll learn the truth over time.
In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light-years long, which is like the length of 2 Milky Ways. Turns out one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name, Planet 9, in our solar system. If it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon, equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found 2 supermassive structures called the Fermi bubbles and Rosetta bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them, a space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light-years away. Some think that this strange question mark is probably the result of 2 or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres. Hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else, the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare, massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old, but the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby. So what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, they think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The titanic black hole in question is between 100 million and 1 billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light-years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang. If you somehow fell into a black hole, it might change your future and erase your past. Well, at least theoretically. Let's start with the real world we live in. Here on planet Earth, your past can definitely define your future. But imagine you're not on Earth, but somewhere out there in the endless universe, and you stumble upon a certain type of black hole. The one that a UC Berkeley mathematician found. Not to mix it with a regular black hole, let's call this type, what about a benign black hole, huh? So here's why you need a specific black hole. Thing is, you're highly unlikely to stay alive in a regular black hole. But according to some calculations made by a postdoctoral fellow, Hinz, from UC Berkeley, this specific type of black holes we agree to call benign ones might expand at an accelerating rate. This is what makes it possible to survive the transition from our deterministic world to a black hole, which is not deterministic. Let's imagine you survived that passage, and now you're moving towards the center of a benign black hole. It's impossible to picture what's inside, and if you, as a traveler, could actually get into a black hole, you'd never be able to communicate to the outer world what interesting things are hidden in it. But it's not what interests us for now. We need to know how to get rid of the past. Hinz, the mathematician you already know, studies non-rotating black holes that have an electric charge. The most important thing about them is that besides the event horizon, they also have the Cauchy horizon. And here's the point. The Cauchy horizon is the place where so-called determinism simply breaks down. This may sound too scientific, but let me explain it to you. The Cauchy horizon is the place where your past doesn't determine your future any longer. So, here's a mathematically proven and apparently working method of how to get rid of your past. All you need to do is get into space, find a specific black hole, make it to the center, and get to the Cauchy horizon. However, if it sounds too complicated, you can simply try not to make mistakes here on Earth. Yeah, ideas like your past gets cancelled, you have an infinite amount of options of how your future will evolve, and all that jazz sounds as unrealistic as they are appealing. Like, imagine no one knows you failed to get into college and get a degree, but from now on, you have every opportunity to do whatever you want. But only theoretically. In reality, once you get into the black hole, not that specific one we've already talked about, you're most likely to disappear once and for all. But hey, don't be sad. I'm only talking about your current physical form. It's a bit deeper than it might seem. Thing is, there's a curious principle of quantum mechanics that can be explained in a simple way. For starters, imagine that you're not a human being, but just information. You have your experience, your background, and your thoughts. All of these are the information you are. Now, let's make it even simpler. Imagine a USB drive or a book. Both of these things contain information. If you smash a USB drive that contains music and movies, it won't exist anymore in its physical form, but the information it had will never stop existing. Same with the book. If you burn it, the information it has doesn't get burned. it continues to exist, but in another form. So, this fun theory claims that even though someone passes the horizon of events, which is a point of no return before you get spaghettified, they don't stop existing. In simple words, these universe travelers still exist, but in the form of information. Now let's go back to the black holes. According to Stephen Hawking, black holes emit radiation. Radiation makes them shrink, and with time, I mean much time, a black hole can shrink so much that it eventually disappears. So what happens to the astronaut who got entangled in a black hole if it disappears? Nope, they won't be ejected from the black hole in the way they used to exist. However, they will still be ejected from there, but in the form of Hawking radiation. But it's just a theory. Right, you remember that no one knows exactly what happens in the black hole? Another theory says that what happens in the black hole doesn't really stay in the black hole. Sounds like a good alternative to Las Vegas if all the flights for the weekends have been booked. Some scientists believe that a black hole might have a portal where you can turn back time. According to this theory, there's a white hole at the end of a black hole. If you get there, you can undo things. Like, you broke your mom's favorite vase? Hop into the white hole and it'll be as good as new there. You cooked a scramble and made a fresh orange juice, but somehow lost your appetite. It's not a problem if you cook it inside a white hole. Voila! The eggs are unbroken. The oranges are uncut and juicy again. No more food waste. Alright, turning back time sounds really cool, so I guess we might actually need a black hole to help us out. If a black hole was made in a, let's say, lab, it could devour things until it grew big enough to consume the entire planet. First, it would munch on the Large Hadron Collider, which might possibly create something similar to a black hole here on Earth. Next, Geneva, where the Large Hadron Collider is located. Then the whole country of Switzerland, then Europe. At that point, it wouldn't be long before the Earth was gone too. Luckily, if a black hole did appear, it would be so small that it wouldn't be able to do anything. Black holes actually produce a lot of energy and release it, often as heat, like a furnace. That means they will fade away when they run out of fuel. Even if a stable microscopic black hole was created, it would grow so slowly that nothing would happen. Assuming that it survived long enough to absorb the tiny particles around it, a black hole of this size would take super long to get even a pound of weight. I won't be around then. But a black hole on Earth could be a great thing. Even a relatively small one may emit enough energy to completely power humanity. We're talking a lot about food, huh? Let's not forget about spaghettification. The concept is quite simple, by the way. It's all about gravity. Imagine you're playing with chewing gum. With your force, you could easily stretch it so instead of a regular piece, you can get a long and thin one. The same happens to you. Black hole force is enough to stretch you as if you were a piece of chewing gum. Gravity holds you tight on one side, which makes you stretch. You may wonder, how come you don't get spaghettified on Earth if there's gravity too? Easy peasy. It's just too weak to do that with you. If you asked a butterfly to stretch the gum, would it be able to do that? Not likely. Their tiny limbs are just too weak. Same here. The Earth is just too weak compared to a black hole. So, if you were wondering whether you'll ever reach 6'6", it may never happen on Earth. But once you're in a black hole, you can go far beyond those mere 6'6 inches. Your best height moment won't last long though. If you stretch the chewing gum at one moment, it will simply tear apart. The same will happen to you because of spaghettification.
Well, let's go to Antarctica. Come on, you've got time. Remember to dress warm. Here we are, in the middle of endless snow-white plains and ice. The temperature in some places drops to a face-freezing minus 136 degrees Fahrenheit. It's so cold that if you throw hot water out of a mug, it will most likely land in the form of an icicle. But this cold is hot compared to the absolute zero definition. Scientists measure it on the Kelvin scale, where 0 is the lowest point. And that's why there is nothing colder than this temperature. All objects consist of atoms and molecules. When the temperature of any object rises, its molecules move quickly and chaotically, producing kinetic energy. If the temperature of an object drops, its molecules slow down in motion, and their energy decreases. So, absolute zero is when the particles stop altogether. There's no movement, which means it's impossible to make it colder. 0 Kelvin is equal to minus 459 degrees Fahrenheit, so that's like 3 times colder than in Antarctica. So, imagine that scientists created a vacuum room and filled it with gas at absolute zero. What happens if a human walks in there? I can't imagine that this turns out well, so let's send Bob in there. But don't worry, he's a crash test dummy. A little background first. When a hot object comes into contact with a cold one, its molecules exchange energy. Fast-moving particles transfer their energy to slower-moving ones and begin slowing down themselves. Then an equivalent exchange occurs, and the temperature equalizes. But by default, the molecules move quite slowly until they're charged with energy. And at the same time, if you have a heated object, you will need more power to cool it. Yeah, it's a bit confusing. So let's go back to where the fun begins. Yes, if you go to absolute zero, you will freeze in seconds, because all your molecules will start to slow down. But what will happen to the body? Well, let's follow the internal adventures of Crash Dummy Bob. First, its blood vessels narrow in the coldest places. The body distributes blood from frozen areas to vital organs like the liver, kidneys, heart, and brain. It's like emergency mode. The mannequin's body stores energy and blood for the most important, taking it away from less important areas. Then, a most dreadful thing begins. The body consists of billions of cells. When their molecules come into contact with a cold temperature, they slow down and freeze. Remember what happens to water in a frozen state? Remove the bottle from the freezer and let it defrost at room temperature. You'll see that the volume of liquid will decrease after a few hours, and when the water freezes, it increases in volume. And the human body is more than half made up of water. So, inside our mannequin, its cells get covered with sharp ice crystals that tear the internal structure of the cells. The muscles and blood vessels of the dummy are torn. Its skin gets a dark blue shade, and its blood freezes in its veins. A couple more seconds, and the dummy freezes completely. Absolute zero temperature stops all internal processes. Hey, Crash Dummy Bob said he wanted to chill, but this is ridiculous. Meanwhile, molecules are not only in living objects. Particles are everywhere, and absolute zero affects them too. The rays of light get the lowest energetic position. Photons slow down, and they can't move at the speed of light anymore. Okay, now it's time to finish the experiment. Something's going wrong, and the story becomes fantastic and hypothetical. Scientists can set molecules in motion, and the neighboring moving particles don't give them their energy. For some reason, the gas can't absorb the energy. Its frozen molecules slow down the others. The gas penetrates through the walls of the vacuum room and starts a chain reaction. The molecules freeze one by one. It's like they take a nap and charge all the matter around with this sleep. The gas area is expanding. Laboratory walls, doors, and windows are frozen. Scientists are covered with ice. Then the cloud goes outside the building. It's like a white spot that keeps growing and growing. The sun's rays get there, but can't move inside too fast. The zero envelops grasses, trees, roads, and cars. Scientists begin to sound the alarm as soon as a whole city gets inside the absolute zero clouds. The stopping of moving molecules occurs so fast that ice crystals don't have time to damage the skin and body in living bodies. It's not even freezing, but canceling existing life. Oxygen and carbon dioxide molecules are frozen. The air gets denser. Here a guy freezes in a jump and remains in the air. Here a frozen bird continues to hang in the air. Things inside the cold air are similar to a 3D picture. Everything froze in motion. It's like someone took a screenshot of a lifetime and printed it. And while the cloud of absolute zero continues to spread, scientists are rushing to solve the problem. The gas is growing and diverging in all directions. If it swallows the whole Earth, it will stop all the chemical processes on our planet. And without these processes, our home will become just another space rock, a lifeless piece of matter stuck in time. However, the real catastrophe will happen not when it envelops the entire surface of the globe, but when it reaches the core of our planet. This can lead to the release of energy that will destroy the planet. Perhaps the core may resist the absolute zero, but in any case, people are not going to wait for this to happen. The cold gas meets a volcano. Lava flows emit a deafening hiss and freezes. Black clouds of steam billow into the air. The cold cloud penetrates into the volcano. The collision of cold and hot temperatures releases energy. The volcano erupts and launches not fireballs, but sharp icicles of frozen magma. Meanwhile, heavy rains are beginning to fall all over the planet. When warm air collides with cold air, it moves away because it has less density. The liquid appears in the atmosphere and it forms clouds. Therefore, while the giant cloud freezes one part of the planet, rain clouds drench the other. And now scientists have finally come up with a solution. They've created a gas with an altered molecular structure that can stop 0 Kelvin temperature. So imagine you're heating water. The stronger the water molecules increase their kinetic energy, the hotter the water becomes. The molecules are moving faster and faster, but not all particles move equally fast. Some of them have medium and slow energy. Moreover, the low energy state of the molecules is more likely. This means that only a few particles move really fast in hot water. This distribution of low and high charge particles is called the Boltzmann distribution. The distribution is everywhere, both in hot and cold objects. If we look at any object at the molecular level, we'll see that there are many more slow-moving objects than fast-moving ones. So, scientists have come up with a solution. They create a gas that works in the opposite direction. It has more moving molecules inside this gas than slow ones. Scientists hope that this gas will wake the sleeping particles up in the absolute zero cloud. So, two gases collide with each other. The cold cloud can't freeze the reverse Boltzmann distribution cloud. There are too many active molecules. So, billions of active molecules charge the frozen ones with energy. All the molecules start moving and share the neighboring ones with their energy. Objects inside the gas cloud begin to wake up. People are slowly coming to their senses. As soon as the molecules come into minimal motion, they start to receive energy from the sun's rays. The particle movement is distributed equally between the two gas clouds, and life returns to normal. The molecular order has been restored. Right. And our little fable here comes to a happy, if not entirely credible, end. Bottom line here, don't worry. Scientists created absolute zero artificially, and it'll never happen naturally. There's no such temperature anywhere in the universe. Particle movement remains even in space's farthest and darkest corners with record low temperatures. The appearance of absolute zero is impossible because there will always be molecules around that move and share their energy with each other. Oh, by the way, no humans, animals, or Crash Dummy Bob were harmed in the making of this video. Are the lawyers happy? Okay.
You might not think about gravity much, but it affects everything we do. It's the reason why things fall down instead of flying up. It keeps us connected to the Earth, so we don't float away into space when we jump. But for physicists, gravity is something more. It's a fascinating puzzle that needs to be solved to understand how the universe works, and they're on a quest to uncover its secrets. So what's so mysterious about it? Let's see. We've learned a lot about gravity from the legendary Isaac Newton. He was the first to invent the law of gravitation. He taught us that any two objects in the universe can't help but be attracted to each other. It's like they have this secret gravitational crush going on. How strong this attraction is depends on two things. How big the objects are, that is their mass, and how close they are to each other. But here's where it gets cool. Gravity isn't just a two-object dance. It's a complex space choreography. Take our solar system, for example. The sun plays the lead role, using its gravitational pull to keep all the planets in their orbits. But each planet also has its own gravitational mojo, tugging at the sun and even its neighboring planets. Then, a few hundred years later, another hero, Albert Einstein, took gravity to a whole new level. He described the theory of general relativity. According to Einstein, gravity isn't just a regular force. In reality, it's curving and warping the fabric of space-time. Think of it as a heavyweight champion sitting on a rubber sheet. The sheet bends and curves under the weight, and the smaller objects nearby can't help but roll towards the heavy weight. Now, even though we can't see space's curves with our own eyes, we can see what happens to objects that get caught in its grasp. Getting pulled by gravity is like being caught in a whirlwind of forces. The caught object starts spiraling downward, just like a coin in those penny slot cyclone machines you find at tourist shops. Or it might move gracefully in circles, like bicycles racing around a velodrome track. Gravity is the primordial force that guides our entire world. Without it, there would be no stars, no galaxies, nothing. But where does it come from? Well, that's the million-dollar question. And we don't have a complete answer just yet. But we do have some guesses. First of all, we know that gravity is more than just a feature of space. It's a force that pulls things together. Surprisingly, it's the weakest force among them all. But let's take a different look at gravity. Something that may surprise you. Instead of being a force that directly pushes or pulls objects from a distance, it's more like a dance. Gravity, as amazing as it is, doesn't perform alone in this dance. It shares the spotlight with other forces, like electromagnetism, for example. Let's imagine two electrons. There are dancers. Now, they don't directly push or pull each other like you might expect. Instead, one electron creates a special kind of field around itself, like an invisible force field. This field sets the stage for the show. The other electron senses this field and starts to twirl and interact with it. It's like they're following some choreography. And when we watch this dance, it looks as if the second electron is being pushed or pulled by the first one. But in reality, it's all about the intricate movements and interplay between the dancers and the field they're dancing in. The dancers never touch each other directly, but their interactions through these fields make it seem like they're connected. It's a magical display of fields and movements coming together to create the illusion of forces at play. The thing we call gravity. So even though it's not a force in the usual way, it behaves like one. We call it an emergent force, because it emerges or comes out from the way space and objects interact. Which is why, if we want to get technical, some scientists prefer to avoid the words gravitational force and opt for the term interaction. It's just a way for particles to mingle and exchange energy and information. Electromagnetic interactions, gravitational interactions, they're all part of this grand soiree. At least that's one of the theories. Some scientists also think that gravity might be made up of tiny particles called gravitons. These sneaky particles work behind the scenes, making objects attract each other. However, we haven't been able to directly see these elusive gravitons yet. So, according to this theory, gravity is both a force and a potential particle. As you can see, we have some struggles with explaining how gravity works on a large scale. But at least we have a good understanding of how it behaves in certain situations, like how planets orbit the sun, or how objects fall to the ground and stuff. But what happens when we zoom into the atomic scale? And what if we venture into the depths of black holes and the Big Bang? Now here's where gravity's wild ride goes off the rails. First, let's enter the realm of quantum mechanics. There's something peculiar that happens in this tiny world. Gravity, the force that pulls things together, seems to take a back seat. On a microscopic scale, other forces like electromagnetism take the spotlight and become the superstars. They're overshadowing gravity, and this leaves scientists scratching their heads, wondering, is this possible? Why does gravity suddenly fade away? So far, we have no idea. And when it comes to the grandest scales, where immense objects like black holes, gravity takes on a whole new level of complexity. For example, inside a black hole, laws of physics and gravity, as we know them, basically fall apart. It also decays when we try to understand how gravity behaved immediately after the Big Bang. Where did it even come from? We have no idea. In other words, we find ourselves in a cosmic fog when it comes to understanding gravity. But fear not, scientists are working hard to learn more about this enigmatic, emergent force. They're doing all sorts of experiments and using fancy technology to crack its code. Even though we still have a lot to figure out, we're making progress every day. For example, have you ever heard of gravitational lensing? It's It's like a mesmerizing magic trick. Imagine a beam of light as a fearless explorer, taking a straight path through the universe. But as it encounters the gravitational pull of a massive object, the light's journey becomes a wild roller coaster ride. The gravity of the massive object bends the fabric of space-time, creating a funhouse mirror effect. Our brave beam of light finds itself curving and twisting around the massive object, following a new unexpected path. But as the light changes its trajectory, it also reveals to us distant and hidden wonders that would have remained invisible otherwise. The light can magnify, distort, or even create multiple images of faraway objects. So all the things that have been playing hide and seek with us finally become visible, like black holes. There's also a mind-blowing idea called gravitational waves. Einstein predicted their existence tens of years ago, but only recently have we finally been able to confirm them. And that was a huge breakthrough in the science world. These waves carry the echoes of cataclysmic cosmic events, such as the collision of massive black holes or the birth of newborn stars. Just like dropping a pebble into a serene pond, these crazy events cause a ripple effect. But instead of water, it's space-time itself that ripples and warps. Scientists have just recently developed a way to listen to these whispers. They've created instruments capable of detecting these gravitational waves. These instruments, known as interferometers, are like ears that are finely tuned to catch the subtle vibrations of the universe. But one thing's for sure. Gravity is a superstar that shapes our universe. It keeps everything around us connected and rules our entire universe. The quest to unveil its ultimate secrets continues, and it's a thrilling adventure for scientists and curious minds alike.
Has your trusty phone ever let you down? More times than you can count? It always seems to run out of juice at the worst possible moment. You forget to top it off, or you end up in an area with no service. And let's not forget how useless it can be in an emergency, like during a tornado when there's no signal. But fear not, there's a cool project called Meshtastic that uses a wireless protocol to keep you connected with your friends. It's like magic, using a radio band called LoRa for encrypted messages. It works in literally any external conditions. Plus, each device can act as a repeater to extend the range of your messages. Perfect for disaster recovery or just keeping tabs on your kids. For less than $25, you can get a starter kit to join the Meshtastic fun. Add a GPS module and a battery and you've got your own private channel. No more stressing when your kids are out and about. You can instantly see where they are. And if you're feeling daring, you can even send low bitrate audio through the airwaves. Now I'll bet there's a bunch of things your car just can't do. Can it lean into corners? Yeah, I don't think so. What about adjusting its own width to park easier? I know your answer is no, but let me show you something then. This cutie is called Trigo EV, and even though it looks like a futuristic stroller, it's actually a fully functional quadricycle you can totally drive. It was initially created for delivery and car-sharing purposes, but it turned out cooler and way more comfy than expected. If you ever find yourself driving this electric, let's call it a car, shall we? You won't need anything else but a tiny patch of land to park it. It has a maximum speed of 56 miles per hour. Not bad for such a tiny car. In cruise driving mode, it measures 58 inches wide, but a mechanism allows the front wheels to retract toward the chassis, reducing the width to 34 inches. The electric four-wheeler weighs slightly over 1,000 pounds, with a total permissible mass of around 1,600 pounds. Right, it all looks futuristic and fun, but I feel safer in good old SUVs. Ever wished you had an extra arm to help you out when your hands are full? Scientists have figured out how to control a robotic third arm using just your diaphragm muscle. It's as easy as pie, if pie is easy. This awesome discovery was made in Switzerland as part of the super cool Third Arm project. They had volunteers wearing exoskeleton arms and a sensor belt to track their diaphragm movements, all while navigating a virtual world in VR. After over 150 sessions with 61 volunteers, most people found it a breeze to control 3 arms at once. They could even multitask, chatting and looking around while using the third arm. Now recently, a new fully autonomous delivery service with fast food joints was launched. This means no people involved from pickup to drop-off. It's called Flytrex, and it's been delivering using drones since 2017, teaming up with big names in retail and food to bring you quick and cheap deliveries. They're currently flying high in North Carolina and Texas, with plans to expand nationwide. Their goal is to make deliveries faster and cheaper using their trusty drones. Your order could be at your door in as little as 5 minutes after it's ready. Now, that's speedy. Flytrex got a huge increase in customers and even FAA approval for long-range drone deliveries in 2023. Partnering with big brands like Unilever and Papa John's, they're definitely on a roll. More a pizza roll. The Monocab Owl project is all about making a super cool monorail vehicle for getting around in rural areas sustainably. The Monocab is a clever little autonomous monorail vehicle that can balance itself on a regular rail without any extra support. Its slim design allows it to zip along single-track lines in both directions, perfect for some unique rail mobility ideas. It's like a fun service-on-demand option that's way more exciting than your usual transportation choices, especially for reviving old railway lines in rural areas. Everyone on the Monocab Owl team is stoked about shaking things up in rural mobility. Right now, there's a lack of good, eco-friendly and budget-friendly options for getting around in less populated areas. Reactivating old railway lines is a great start, but we need some fresh ideas to really make it work. That's where these small, self-driving rail vehicles come in. They bring together the best of rail travel with on-demand booking and a cool digital navigation system. Look here! Can you identify what this weird-looking object is? It's a mobile solar container with foldable solar panels for green energy on the go. Just pop out the panels, unfold them, and you're good to power up equipment and properties with green energy wherever you are. The solar container can extend up to almost 400 feet in length when fully unfolded and has 240 solar panels. It's perfect for both on- and off-grid uses, like rescue missions and outdoor events. And it only takes about 5 hours to set up. Easy peasy. There's even an automatic conveyor system for easy folding and unfolding of the panels. Just push a button and start harnessing solar power. Solar Kant, the Austrian company that invented it, estimates this mobile solar container can power around 32 households. Virtual meetings are all the rage nowadays. Remote chats are cool, but let's be real, they're no match for face-to-face meetings. We can see each other, hear each other, but it's still pretty flat and 2D. Or, shall I say it was flat? The thing is, Holobox from HoloConnects is bringing holograms to life. This super cool device lets you project a life-size hologram of yourself or anyone else inside a funky box. Just plug it in, connect it to the internet, and voila! You've got a hologram ready to go. You can even connect multiple boxes to showcase big stuff like cars or anything else. Now, holograms are a massive game changer for remote communication. Imagine chatting with someone and seeing them in 3D like they're right there with you. Plus, it adds a personal touch to presentations, training sessions, ads, you name it. What do you think? Does this look cool or creepy? Check out the latest creation from a rockstar team of engineers at NASA Ames Research Center and KBR, a robot system that can autonomously build structures using lattice blocks. Their paper in Science Robotics explains how these robots and blocks work together to create amazing things. Designed for future lunar missions, these robots can lay down foundations for shelters before astronauts arrive. 3 robots work together to carry and connect blocks with twisty edges, similar to assembling IKEA furniture. They have already built impressive structures, like a shelter made of 256 blocks in just over 4 days. Imagine what they could do on the moon. Experience the interactive pearl sculpture by Breakfast. No food implied, just the name of the company. It's placed on a huge cruise ship called the Icon of the Seas. The stunning creation imitates the ocean's vibes, with rolling waves and shooting stars, each tile placed in a neat Fibonacci sequence. Using real-time data from the Caribbean, this sculpture changes constantly to match the current weather and tides, bringing the ocean to life before your eyes. Yeah, this invention won't change your life, but it's meant to nurture your soul. Have you heard about the Seattle-based startup Jetoptera? They're developing innovative vertical takeoff and landing vehicles with bladeless propulsion systems, promising a future of quiet, safe, and fast urban flight. By 2050, 70% of the population will be living in cities, leading to crowded streets. But Jetoptera's fluidic propulsion system offers a solution, using air pressure technology for silent operation. Jetoptera is also working on a high-speed VTOL for the U.S. Air Force, with plans for passenger-carrying prototypes by 2026. Well, that's exciting.
On November 2nd, 2000, the first crew of astronauts arrived at the International Space Station. Almost 25 years have passed, and the ISS still remains one of the most outstanding projects created by humanity. During all this time, 280 astronauts from 23 countries have visited the station. This place has become a floating laboratory for space research where people from all over the world come together to explore our universe. The station remains a source of inspiration for writers and movie directors. This is not only one of the most important parts of the scientific field of humankind, but also an important attribute of pop culture. The station makes one circle around Earth every 90 minutes, and very soon, one of its next circles will become the last one. NASA is going to destroy the ISS. Space and science fiction fans may feel sad at this moment, but there are good reasons for such a difficult decision. The ISS, like any physical object, is not eternal, especially in the conditions of outer space. Yes, there's no oxygen, atmosphere, oxidation of materials, and air pressure, but the ISS is moving at an altitude of about 260 miles above the Earth's surface at a speed of 17,900 miles per hour, which is almost 20 times faster than the speed of sound. Also, the space around the planet is filled with debris consisting of broken satellites. And don't forget about stardust and tiny pieces of meteorites. What if something crashes into the station and blows it to pieces? Yeah, NASA is tracking the largest pieces of debris, but there are more and more of them every year. Under such conditions, the station can't serve us forever. The parts are wearing out, and the station fasteners are becoming weaker and require frequent repairs. The station was supposed to only last 15 years, but it will eventually last twice as long. In 2030, astronauts will leave the ISS, and then it will be destroyed. But how can this be done, given the size of this object? It weighs 430 tons and is the size of a football field. It is the largest object after the Moon that flies around our planet. People made 42 launches into space to construct this gigantic structure. Given its size and close location to Earth, destroying the station is a big risk. Just imagine it disintegrating into hundreds and thousands of fragments and falling to the surface of our planet. Yes, some of these chunks will burn up in the atmosphere. Others will fall into the water. But some large parts can fall on cities. It will be a devastating meteor shower. This option is too dangerous, but this is exactly what NASA is about to do. The disposal of the station will probably be a more complex operation than its creation. Of course, scientists have considered other options besides the destruction. For example, we could return all the astronauts to Earth and then send the station to a higher orbit so that it would fly there forever. However, such an operation would be too expensive. In addition, changing the orbit might not save the station from collapsing. We definitely don't need a huge piece of metal that could fall apart at any moment over our heads. That's why destroying the station is the only option. To destroy the station, scientists plan to send it to a lower Earth orbit, then carry it through the atmosphere, where some parts of the station will burn, and after that, submerge the station in a remote part of the ocean, where ships don't sail and fish don't swim. By the way, this place is called Point Nemo, and it's located in the South Pacific Ocean. This is the farthest point from land. For many years, people have been dumping space debris and failed satellites there. It's considered one of the most lifeless and loneliest places on Earth. NASA plans to drop the ISS there, but this requires very precise calculations and control. The operation can't be fulfilled without a special space tug, and this unique machine will be invented by Elon Musk's SpaceX company. Musk signed an $845 million contract with NASA. According to it, the station should be safely destroyed by 2031. And that's how this cinematic operation is going to happen. The device that will lower the ISS to Earth will be built according to the design of the SpaceX Dragon ship capsule. Scientists plan to calculate the details of the station's flight trajectory, all angles of incidence, and the speed of movement. No mistake can be made, as any miscalculation will lead to disaster. Our planet is a giant object with a powerful gravitational force that attracts other objects to itself. The ISS uses thrusters to resist this attraction and stay at the same height. So, first of all, the station will need to reduce its resistance. If necessary, it can use the engines to adjust the route. From an altitude of 260 miles, the station will descend into an orbit of 205 miles above Earth. After that, SpaceX will launch its space tug. All this will happen about a year before the scheduled date of destruction. During this time, the astronauts will fold up scientific equipment, say goodbye to the station, and return home. This sad moment will be recorded on camera and posted on the internet. After that, the whole planet will watch the dramatic finale of the ISS. The space tug will dock with the station and transport it to the lowest point of the orbit, approximately 90 miles above the surface. There, the station will experience huge air resistance. It will become increasingly difficult to control the fall. The tug must be equipped with powerful rocket engines to correct the flight. Scientists will control the shuttle, calculating the trajectory of the fall. Then, SpaceX's device will begin to push the station down. The giant space object will pass through the thickest and most dangerous layers of the atmosphere. It will burn down the station, which will be falling apart by that time. This will be a mesmerizing fire show. Some parts will burn up in the air, others will pass through the barrier. At high speed, incandescent parts will collide with the surface of the Pacific Ocean. Millions of people will be watching the last flight of the space legend on the screens of their gadgets and TVs. The water will be getting closer, and boom! Pieces of those stations will crash into the water with a deafening noise. Many smaller fragments will fall nearby. The entire station will cool down quickly and sink to the ocean floor. Mission completed. But the history of the station won't be over. Point Nemo is 2,700 miles away from the nearest land in any direction. But the best way to get to it is from Easter Island, Chile. What if rich people from all over the world flew to Chile to then travel to Point Nemo? Just imagine, covering thousands of miles just to get to the ISS crash site. People will descend in bathyscaphs to the ocean floor and take out the wreckage of the station. Someone might start selling them. Someone will keep them at home as part of a collection. Perhaps NASA will retrieve some modules of the station to put them in a museum. But what will happen once scientists finally get rid of the ISS? The space laboratory is used for research in outer space. After its destruction, research will continue, but on a grander scale. Humanity has to explore Mars, remember? For such an important mission, it's necessary to prepare astronauts in conditions close to those on the Red Planet. The Moon is the perfect place. NASA is conducting the Artemis mission. We'll explore the lunar surface, and we will go on a long journey to Mars from there. At the end of 2022, NASA launched a probe that flew beyond the Moon. The next flight will be launched with people on board. The third flight will be the first human outing on the Moon since 1972. Gradually, step by step, the agency plans to land several astronauts and space station modules on the surface of the Moon. They will build large research bases where they will prepare for the first ever human flight to Mars. By the way, would you agree to go on a dangerous journey to the Red Planet? Write your answers in the comments.
NASA is on the hunt for Dyson spheres. Turns out there are 60 stars that give off weird light patterns. This means there might be some extraterrestrial technology nearby. A team of scientists has developed a new way to search for advanced civilizations by looking for Dyson spheres. All forms of life, from microbes to us, need energy in order to survive. As living creatures keep evolving, their energy needs grow. We started with small fires, then moved on to coal, oil, and eventually solar panels. Now imagine a super advanced civilization that has used up all the energy sources on its planet. What's next? Their host star, an almost limitless power source. This is where the idea of Dyson spheres comes in. It was made up by the physicist Freeman Dyson in the 1960s. This idea says that, hypothetically, we could build an incredibly big structure around a star to capture its energy, like some sort of gigantic solar panel. Advanced civilizations could use it to power their planet and even interstellar travel. Right now, something like this would be impossible for us to build. But maybe someone else in the universe has managed to pull that off. Scientists gathered lots of data from surveys of stars. They analyzed over 5 million objects and found some candidates. Of course, extraterrestrial civilizations might have completely different technology, so astronomers aren't looking for actual giant shells around stars. Instead, they're looking for technosignatures. These are weird things that might indicate the presence of something technological and can't be explained by known natural sources like galaxies or nebula. For example, a structure like a Dyson sphere could give off unusual infrared radiation. This is because, while absorbing a star's energy, this structure would give off crazy amounts of heat. Out of millions, they identified 368 potential candidates. Further filtering left them with only 7 objects that could be Dyson spheres. Now usually, weird infrared flickering happens from giant crashes in space, like planetary collisions. Warmed-up dust and rocks get scattered around and give off strange lighting patterns. These are called extreme debris disks. The researchers think these 7 objects could be M-type stars, also called red dwarfs. These are stars that are very small on a space scale and a bit fainter than our Sun, a yellow dwarf. Stars like that don't usually have warm dust and rocks around them, but scientists need to do more tests, like looking at the light in detail, to be sure about their discovery. There was another study that found 53 star candidates with similar excess infrared radiation. But these also need to be checked. Scientists plan to use advanced tools like the James Webb Space Telescope to take a closer look at all these candidates. One famous candidate is Tabby's star. Scientists even made a joking name for it because the paper about this star had the subtitle, "Where's the Flux?" Think of an acronym yourself. Now, it's a bit hotter and more massive than our Sun. It's caught NASA's attention because of its unusual, irregular light dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turns on and off a flashlight. At first, you might think this is just because some big planet is passing in front of it, or a comet, but we're talking up to a 22% drop in light. No planet could manage to eclipse a quarter of a star, and that's where the name comes in. So, another explanation is a Dyson sphere or some similar megastructure. Someone also suggested that the dips might be caused by fragments from a broken exomoon orbiting the star. There are other stars that show similar traits, but there's no solid evidence to support this. So for now, scientists just don't know. So astronomers are on the hunt for any giant structures. There are many variations of what a Dyson sphere could look like: rings, bubbles, a swarm of satellites, a giant shell, and so on. A Dyson shell would be a solid, rigid shell completely enclosing the star. This is the most extreme option, the hardest one to build. Also, if other civilizations built that thing, it would fully cover the star's light, and we simply wouldn't see it. The inner surface of this shell could be lined with habitats, and we could simulate gravity by rotating the structure around the Sun. A Dyson swarm is the simplest option, a bunch of solar-collecting satellites and habitats orbiting the star. It would be a lovely place, with people living in many space stations or mini space houses within the swarm. Each little habitat would have its own air, life support systems, and artificial gravity. We could also grow our little farms there. And imagine the view. We would see a constant bright sky with other habitats visible across the expanse. A near unlimited energy of a star would mean we could advance our technology very fast, manufacture tons of materials, and terraform planets within the star system. But building and maintaining a Dyson sphere would require advanced robotics, AI, and tons of money. It would take us centuries or millennia to get there. Now, giant megastructures aren't the only things that scientists are looking for in order to find extraterrestrial life. They also look at the planets. Now, planets must have certain characteristics to be potential homes. There should be liquid water and an energy source, something to drive these reactions, creating the building blocks of life. Turns out such conditions aren't rare at all. Our search showed that there might be more than 60 billion potential habitable planets in the Milky Way alone. Unfortunately, we can't look at them directly or land there. So we have to use tricks, like detecting water and good gases in their atmosphere. Recently, the James Webb Space Telescope found possible signs of life on a planet called K218b, which is pretty close, about 120 light-years from Earth. This planet is 9 times the size of Earth. It has clouds of liquid water but a different atmosphere, full of gases like methane, carbon dioxide, and dimethyl sulfide. Regular oxygen-breathing life wouldn't do well at all there, but on Earth, dimethyl sulfide is produced by life forms like phytoplankton. They also discovered that weird wiggly planets could be signs of advanced extraterrestrial civilizations. In our solar system, each planet has its own orbit. But the universe likes to surprise us. Surprise! Models show that there might be planets that share the same orbit. For example, it's possible if the planets are evenly spaced around the star, minimizing their gravitational impact on each other. Or the so-called horseshoe configuration, when planets speed up and slow down in relation to each other, moving in funny wiggly ways. These horseshoe systems can hold up to 24 planets. This is one of those things that are possible, but very unlikely without some help. Normally, gravity would immediately destabilize such systems. This means that if we ever find a star system with 24 planets sharing orbits, it might indicate that some advanced civilization decided to lend a hand. They also might contact us themselves. The search for extraterrestrial intelligence began in the 1960s when astronomer Frank Drake started listening for radio signals from space. Today, they persist. Astronomers listen for leakage radiation from other civilizations, which are radio waves unintentionally sent into space from everyday activities. Recently, they detected radio waves from YZ Ceti b, a planet super close to us, just 12 light-years away. This means it might have a magnetic field, invisible shields that are very important for protecting life from the solar radiation. But YZ Ceti b is probably too close to its star to be habitable. But there are a lot of places for such a signal to come from. It turns out there are 1,000 star systems in our galaxy where they can see us in the sky. All these stars have a perfect view of Earth passing in front of the Sun, making it easy for potential extraterrestrial astronomers to spot us. So, there are over 1,000 star systems that could be watching us right now. And if we study them, we might one day find evidence of intelligent life looking back at us. Hello!
A team of intrepid scientists have devised an audacious plan to unravel the mysteries of the universe. Their secret weapon? Computation. The very heartbeat of living systems. But what's that? And how will computational zones help us to find extraterrestrial life? Let's find out. In our universe, there are special places called habitable zones. They hold the key to life as we know it. You see, planets are a bit like picky eaters. They have specific preferences for their conditions. Just as we humans need things to survive, planets need their environments to be just right for life to thrive. So, What's the secret recipe for a habitable zone, you ask? It's all about finding that sweet spot where liquid water can exist. Water, as we know, is the magical elixir of life. Planets love to have it flowing or sloshing around on their surfaces. So we need to find the perfect balance. If a planet is too close to its star, things get toasty, and water evaporates into a sizzling mist. On the flip side, if a planet is too far away, it becomes an icy wasteland, freezing water solid and turning potential life into popsicles. But within that perfect middle zone, also called the Goldilocks zone, temperatures are just right. That means planets have the perfect conditions for life to potentially take root. For a long time, scientists have been looking for planets in these zones. And as of January 2023, we have found a total of 63 potentially habitable exoplanets. However, a recent study has changed our view of where we should look for life. Gone are the days of restricting our search to mere habitable zones. Oh no, we're thinking big. Get ready for the computational zones. These enchanting realms could house life forms we've never even dreamed of encountering before. But what exactly are these computational zones? Well, let's see. When scientists search for life in the universe, they usually look for things similar to what we have here on Earth. They imagine creatures living on a planet's surface at just the right distance from their star and using water for important chemical reactions. But what if life can be much more diverse and fascinating than that? Imagine life using different liquids instead of water. Picture life hiding deep underground in icy moons. It's even possible that life doesn't need a star at all. And there might be biological systems that are different from our idea of life in general, but still alive in their own unique way. That's why two clever researchers have come up with a new idea. They want to change how we think about the places where life could exist. Instead of focusing on habitable zones, they suggest looking for computational zones. Think of these computational zones as special kitchens, where the secret recipe for life is being prepared. To make this recipe work, we need three key things. First, we need a variety of special ingredients, like different chemicals. Just like a chef needs various spices and flavors to create a delicious dish, life needs different chemicals for its calculations. Second, we need a source of energy, like sunlight or heat from hydrothermal vents. This energy powers the cooking process, just like heat powers a chef's stove. Lastly, we need a dedicated space, like a kitchen counter, where all the calculations can happen. It's the place where the ingredients come together and amazing things start to occur. In our case, it was our solar system and our planet Earth. Basically, computational zones should have three things: some chemicals, source of energy, and space. This makes a pretty wide sample, isn't it? By focusing on computational zones, the researchers believe we have a better chance of finding signs of life. These zones could lead us to amazing discoveries and show us that life in the universe is much more creative and diverse than we ever imagined. And here's the real mind-boggler. This idea also leads us to think about technology. Yes, AI and stuff. Just as we humans create and use technology, could life itself create its own technological marvels? Life could be biological, digital, or even something completely different. Computational zones give us a fresh way of thinking outside the box and get creative. Now here's another twist in all this research. Turns out that life might be much closer than we think, as if in our own solar system. It turns out that the insides of icy moons, like Europa or Enceladus, answer to all these conditions. They're just as fascinating as the surface of rocky planets. It's like realizing that hidden treasure lies right beneath our feet. Europa is Jupiter's icy moon, which is as old as our Earth. It looks like a half-sphere with a bright icy appearance, an off-white color with a hint of blue. Mysterious dark lines stretch across the moon, forming patterns. It lacks towering mountains or deep basins, but instead showcases dark ridges, grooves, and long streaks. As you move toward the bottom of the image, Europa fades into darkness, leaving us curious about what lies beyond. But the most important thing about Europa is that it's a fascinating candidate for life. First of all, this moon has liquid water in abundance. Scientists believe that there might be an entire salty ocean beneath its icy surface. There might be twice as much water as all the oceans on Earth combined, but life needs more than just water to exist. It requires certain chemical elements like carbon, hydrogen, oxygen, and so on. They're like the building blocks of life. These elements are found throughout the universe and make up a whopping 98% of living matter on Earth. And Europa is believed to have a lot of all these elements too. Perhaps they were brought there in the distant past after a collision with asteroids and comets. Although it's pretty cool that we found organic molecules on Europa, it doesn't automatically mean they are linked to life. These molecules can be created in non-living processes as well, but they still give us some very important clues. And finally, energy. It's like fuel for life. Just like we need food to keep going, all living things need energy to survive. On Earth, plants get their energy from the sun through a cool process called photosynthesis. Plants turn sunlight into food, and when animals eat those plants, they get energy too. But the kind of life that might live on Europa can't rely on sunlight. Europa is covered in a thick layer of ice, so there's no sunshine reaching its surface. Instead, life on Europa would have to find another way to get energy. And that way is through chemical reactions. Europa's surface gets showered by radiation from Jupiter, which is not so great for living things up there, to say the least. However, this radiation can actually be helpful. It helps to create oxygen and hydrogen in Europa's atmosphere. But that's not all. As Europa orbits around Jupiter, it gets flexed and squeezed by the planet's gravity. This flexing generates heat, just like how bending a paperclip can make it warm. The heat from this process can provide energy for life too. So as you can see, Europa's potential life forms have to get creative. But this little moon still has a very high chance of supporting life. It's a fascinating and mysterious world out there. And Saturn's moon Enceladus is also an exciting place where life could thrive. But detecting this life is no easy task. The moon is covered by a thick ice shell with a super deep ocean beneath. Even here on Earth, that would be a huge challenge, let alone on a moon halfway across the solar system. Enceladus is nothing like Earth, so don't expect to find cows and butterflies there. But it would have its own unique ecosystem. Some organisms that rely on chemical reactions for energy. Although life on Enceladus, if it exists, might be extremely scarce. But regardless, we should keep exploring it. Any findings would be helpful for our future missions. All these new discoveries open new possibilities and fuel our curiosity about life beyond our planet. Who knows what exciting discoveries await us in the vast universe? Let's keep exploring and find out.
You know, it's hard not to wonder if there's another form of life out there in the universe when you look up at the night sky. There's this thing called the Fermi paradox. It basically says this: if civilizations that might live somewhere out there in the universe are so common, why haven't we found any signs of them? We look really hard, but we haven't stumbled over any proof that there are other forms of life somewhere in space. And we suspect there could be many civilizations, because scientists have calculated there are possibly billions of habitable planets in our galaxy alone. So, it would seem reasonable to assume that some of these planets could have developed intelligent life, possibly even civilizations that are more advanced than ours. So, the Fermi paradox basically says, hey, where's the party? How come we weren't invited? And one of the potential answers to why we haven't found any other form of life in the universe is something called the Great Filter Theory. This theory appeared in the 1990s, and it says there's a big obstacle or challenge that prevents life from being widespread in the universe. It's called the Great Filter because it suggests that there is a filter that most, if not all, civilizations must pass through in order to become really cool and advanced, like the ones from science fiction movies. But so far, there are no signs of other civilizations like that, or even some real evidence of any form of life. Maybe it's really hard to evolve into a complex life form, or maybe it's really hard to develop the technology to travel through space. Either way, it sounds like a tricky obstacle all intelligent civilizations may face, the one that doesn't allow them to make any progress beyond a certain point. It means they might have come to a certain level of development and then something happened that destroyed them, like an asteroid impact or an environmental disaster. Or they could cause their own demise, and bam, everything they've achieved is gone. So the Great Filter suggests there's some kind of obstacle that stops intelligent civilizations from becoming advanced enough to make contact with other civilizations or colonize other planets. This theory presents two interesting scenarios. The first one says that the filter lies in our past and that we have already overcome it. This would mean we have passed the hardest phase and the test in general. Well, woohoo! But it would also mean that intelligent life is relatively rare in the universe and that we may be the only advanced civilization that exists at the moment. So, the universe could really be relatively empty when it comes to intelligent life. That means the chances that we'll make some friends from other planets and visit them in our super cool spaceships are low. Well, that's sad. But the second scenario is a lot worse. It states that the filter could actually lie in our future. We haven't faced this mysterious and pretty advanced test yet. That means there's still a chance for us to fail. If the filter really does lie in our future, it may mean there are many intelligent civilizations out there, but they're all struggling to overcome the same obstacles that we could face sooner than we think. They may be trying to pass these tests, stay alive, and send us a message that we're not alone and that they would like to visit us too. One of the things the Great Filter theory talks about is the development of artificial intelligence, or AI. As AI technologies become more advanced, it's possible that it could pose a threat to humanity, or lead to unwanted consequences if we're not careful enough with it. There's still hope, though. Not everything is so dark and gloomy. Maybe some civilizations have already passed the Great Filter and are out there in the universe, and they'll manage to send us a message. Maybe a life form that is still not bigger than bacteria is somewhere out there, and they haven't come to the level where they're developed enough to communicate with us. Or maybe we'll be the ones to pass the test and send a message to others one day. Well, either way, scientists are not giving up. They will keep looking for traces of life all around us in space, especially in our solar system. And some of their discoveries tell us we may not need to look beyond our own neighborhood to find signs of life. First, there's Enceladus, a small moon that circles around Saturn. In the beginning, researchers believed it was just a plain rock covered in ice. But in 2005, NASA's Cassini spacecraft took pictures of geysers of frozen water that were spewed from cracks in the southern part of Enceladus. One of the most likely explanations is that there are oceans of liquid water lying under the frozen surface. They remain warm because of the gravitational forces between Enceladus and other Saturn's moons. Water is a key element for development of life, so you never know. Also, scientists have discovered the presence of phosphorus on Enceladus, which is another essential element for life to appear. It's one of the 6 basic building blocks of life, and it plays a very important role in many biological processes, such as cell membrane formation, energy transfer, and such. They believe the phosphorus probably comes from the moon's rocky core and is transported to the ocean through hydrothermal vents. Moving to the next potential location that could contain some form of life, Titan, Enceladus' big brother. It's the only moon in our solar system that has clouds and a dense atmosphere that you'd normally find on planets. And it's the only known place in our solar system, except for Earth of course, that has liquid lakes, filled with methane and ethane, liquid natural gas, but still. Titan is a world that resembles Earth the most. Scientists even believe that conditions there are similar to those Earth had in its early years. Our home planet is closer to the Sun, though, so it's always been warmer. Titan might also have an underground ocean of liquid water beneath its surface. Now, we can't miss Mars when we're talking about the possibilities of life in space. One of the main pieces of evidence is methane scientists found on the red planet. Methane is a gas that can be produced by living organisms, think cows, so it might be an important sign. They also have found organic compounds on the surface of Mars, which are the building blocks of life. Another promising discovery on Mars is liquid water. There could be a lake located under a polar ice cap. and scientists believe it could even contain microbial life. Europa is one of the moons that orbits Jupiter. It potentially has plenty of water, too. There could be a salty ocean under its nearly 10 miles thick crust with more water than all of Earth's oceans contained together. There's likely a rocky seafloor at the bottom of this mysterious ocean. The interaction between the rocks and the ocean could create chemical nutrients that organisms, if there are any, need to survive. Europa's secret ocean probably has hydrothermal vents, too. Those are basically areas where hot water and minerals are released from the seafloor. These vents support a variety of life forms on Earth, so it's exciting to know that there's a possibility that similar life forms could exist on Europa as well. The problem could be radiation coming from Jupiter. It's really strong, and as such, it can be really harmful to any potential life forms there. Any life on Europa would need to have some sort of shield so it could survive such intense radiation. Let's also check the second biggest Jupiter's moon, Callisto. It has many craters, but it's still one of the most geological inactive bodies in the solar system, with no active volcanoes or tectonic activity. That's why its surface is mostly the same as it was at the time the moon formed, which is why it gives us a unique window into the early history of the solar system. And, you guessed it right, Callisto also has a subsurface ocean that could potentially hold life. Fun to think about, eh? Let's test to see how many spiral-shaped objects you can find around you right now. I'll bet there's more than you think. A spiral may be hidden in the flower petals of your houseplants. One might be staring at you from that seashell you brought home from your last trip to the beach. If none of these objects sound familiar, you might want to head over to the mirror and turn to the side a bit. In case you haven't noticed yet, even our own ears are shaped like a spiral. Why does Mother Nature seem to have such a preference for this shape? Many theories wish to explain this weird behavior. One of them is based on the Fibonacci sequence. This Italian mathematician didn't really care much for spirals initially. He was studying rabbits when he came up with this theory. Fibonacci came up with the sequence as a solution to a problem involving the growth of a population of rabbits. Let's recreate his experiment. If you put a pair of rabbits in an enclosed space, how many pairs of rabbits will you find there after a year? To solve this problem, Fibonacci proposed some conditions for his theoretical experiment: that all rabbits are born as a pair, one male, one female. Also, the rabbits can start reproducing after 1 month. More so, each pair of rabbits produces one pair of offspring each month. And lastly, none of the rabbits kicks the bucket at the end of the year. Now, using these assumptions, Fibonacci noticed the following sequence: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. The first two numbers in the sequence, 1, 1, represent the initial pair of rabbits. The next number, 2, represents the number of pairs of rabbits after the first month, one pair of the initial rabbits plus one pair of offspring. The fourth number, 3, represents the number of pairs after the second month, 2 pairs of the initial rabbits plus one pair of offspring, and so on. He soon noticed that his series is made out of numbers in which each number is the sum of the previous two numbers. A lot of other mathematicians have looked at this sequence over the years. They were soon surprised to discover that this system was found in many natural structures, such as the arrangement of leaves on a stem and the arrangements of seeds on a sunflower. If you don't understand why it is so, then grab a piece of paper and a pen. Together, let's try to draw the Fibonacci spiral. You'll have to start with a small circle at the center of your page and then draw larger circles around it without lifting the pen from the paper, using the numbers from the Fibonacci sequence. For example, the first circle is 0 units wide, the second circle is 1 unit wide, the third circle is 1 unit wide, and so on. As you keep adding more circles, they will fit together perfectly to form a spiral shape. The spiral gets bigger and bigger, but it always follows the same pattern based on the Fibonacci sequence. Another famous spiralist was a man named James Bell Pettigrew. He was a Scottish naturalist that became fascinated by the mystery of the spiral shape, which he noticed almost everywhere in nature. He studied it at all scales, from giant nebulae in space to tiny molecules. Despite his research, he couldn't figure out where the spiral came from. He was sure that it couldn't be just a physical thing, and he believed that organs in plants and animals are not only shaped like spirals, but they also work in a spiral way. At the center of lifetime work on this unique shape was the human heart. Pettigrew believed that the heart's spiral structure was the mystery of all mysteries. He also thought this shape was to blame for both its muscular contractions and how the blood seemed to travel within our mighty tickers. The reason why the spiral seems to be everywhere might be really simple: efficiency. Take a look at the basic sunflower, for example. It figured out a way to display its seeds so that it could expose them to the sun equally, without wasting any space and without being limited in their growth. Spiral stairs are another great example too. They just work better. You find it easier to climb them, and they should take less space than the usual ones. We also might be more inclined to notice this shape more than others. That's because a spiral shape, or its proportions, is more aesthetically pleasing to the human eye. It's the reason why interior designers, artists, or illustrators often use these principles in their work. The spiral symbol is also the oldest symbol found in every civilized continent. Some historians believe that the spiral in Asian art may represent the sun, as it has been found on roof tiles from the Tang dynasty near the ancient city of Chang'an. It is also often found at burial sites, and scientists believe it to represent the circle of life, how we pass on and somehow be reborn. This is probably because, in some ancient civilizations, people believed that the sun was born each day, extinguished itself each night, and was reborn the next day. You might have also stumbled upon the spiral as a symbol of hypnosis and dizziness. There's no real evidence that you can hypnotize someone by making them stare into a spiral for a certain time. But its effects on our abilities to focus and our optic nerves are significant. After you've stared at a spinning spiral for quite some time, you'll notice how objects either get smaller or bigger, depending on the direction of the spiral. It's easy to understand why some experience the sensation as hypnotizing. One of the most distinctive features of DNA is its spiral shape. It's also called a double helix. The double helix is formed when two strands of DNA twist around each other, like a ladder being twisted into a spiral shape. This spiral shape is important for many reasons. First, the spiral shape allows DNA to be compact and efficient. The double helix can pack a lot of genetic information into a small space, making it possible for cells to store vast amounts of genetic material in a small area. Second, the spiral shape allows DNA to be flexible and respond to changes in our environment. Because the double helix is made up of two strands that can move relative to each other, our DNA can change its shape. Finally, the spiral shape of DNA allows it to interact with other molecules in the cell. Now, let's look at the big picture. The biggest of them all, that of the galaxies found in our universe. They're also shaped like a spiral due to their rotation and the presence of dark matter. As the galaxy spins, the stars and gas clouds within the galaxy move in a circular direction around its center. This movement creates a spiral shape as the stars and gas clouds are drawn toward the center of the whole system. Additionally, the presence of dark matter, which is a type of matter that does not interact with light, creates gravitational forces that help to shape the galaxy into a spiral. But you don't need to look that far to understand why spirals are important. Your handy corkscrew is shaped like a spiral too, because it makes it easier for you to open the wine bottle. That screw you drilled into the wall to hang a picture, also a spiral. It helps it with some added grip and stability. Got a notebook on your desk? Those pages might be held together by a spiraled wire. It makes it easier for you to browse the notebook without damaging the pages. Even your hair strands might have a curled shape. The curlier the hair, the drier it will be. It means it will get sebum from the scalp down on the strand slower, making it easier to maintain and clean. And before I spiral out of control, we're done here.
For some of us, it's an exciting thing to look up to in the future. For others, its rapid evolution in recent years might even be a bit scary. Either way, this whole AI story sounds incredible. There is even this theory that looks at artificial intelligence and predicts it will go through 7 stages of evolution. Let's look at each one and figure out where AI stands at this very moment. The first stage in the overall history of artificial intelligence is one called rule-based. It sounds basic because, well, it is. But these first iterations of AI were the bedrock of its evolution. They are still the silent heroes that help keep your toast from burning or your car running smoothly on cruise control. How these systems function is they've got a strict rulebook to follow, making them consistent, but not super adaptable. Rule-based systems have been developed since the 50s, but these days, they are a lot more complex. Let's take the next step. Ever visited a website and was invited to interact with a chatbot? That's another type of AI hard at work for you. These more evolved systems are designed to be aware of their context. They are still based 100% on human input, but they can be taught a new trick or two. That's because they can tailor their responses to better fit the situation. Whether they're lending a digital hand in customer service or advising on your next big purchase on a shopping website, their evolution is continuous. The next step of AI on our list is even more specialized. Think of smart computer systems that can become experts in a particular area. They can even be better than humans in some fields, mostly because of their speed, because they can gulp down heaps of information extremely fast. On that note, you might have heard of a game called Go. It's similar to chess, but with many more moves. I mean, some say there are more possible moves in Go than there are atoms in our universe. Well, there was this computer system called AlphaGo. It's like a little student. It had some basic rules to learn Go and a simple aim: to win. And while it did make a few mistakes here and there, humans were there to guide it. In 2016, AlphaGo met its most challenging opponent. It had to play against Lee Sedol, a famed champion of the game. Surprisingly, AlphaGo won with a score of 4-1. Soon enough, AlphaGo Zero was developed. The difference was this iteration of the software was a self-learner. Scientists practically gave it a puzzle to solve without the picture on the box. No human help, no nudges. It had to rely merely on its own brain power. So AlphaGo Zero became a Go-watching enthusiast. It looked at thousands of games and came up with interesting strategies all by itself. And then the big face-off happened. AlphaGo Zero versus AlphaGo. The result should come as no surprise. The second version did win, but with a score of 100-0. All of this shows the amazing stuff machines can do when they try to think like us on a giant scale. But here's where they fail. These types of AI machines are like one-trick ponies. For example, if AlphaGo Zero tried to learn something new, it'd forget all about playing Go. Stage number 4 includes types of AI that, from the outside, look like they're genuinely thinking, or at least are becoming pretty good at mimicking the human brain process. They aren't just playing by the rules or remembering stuff. These systems can read your favorite book, for instance, and they won't just scan through it, but truly grasp the plot, and even try to guess why the characters are doing what they're doing. It's not just about literature, though. They can even try peeking into business numbers and predicting where the money trends might head. Maybe even giving you some cool tips on where to invest. Even further up the scale is a little thing called Artificial General Intelligence, or AGI. Experts believe some of the current systems available online are just starting to reach this stage. These types of software should, in theory, think like us humans. So if you throw a random task its way, it says to itself, "No worries, I got this," and finds a way to solve the problem. Basically, AGI aims to do pretty much anything we can do. Now remember, when it comes to AI, in the grand scheme of things, we're merely starting out. So it's hard to think of an exact definition for artificial general intelligence. That's why a lot of experts have their own take on what AGI really means. Computer scientists might say our human intelligence comes from setting and achieving goals. Should AI software learn to do that, it's comparable to the human experience. Meanwhile, some psychology experts think being human is all about adapting to new stuff and staying alive. If you look at it this way, AI software still has a long way to go. With this following stage of AI development, we're starting to peek into the future. These theoretical software systems are called ASI, standing for Artificial Superintelligence. They'd act like extremely smart computers, capable of thinking better and faster than any human genius. We're not sure about all the amazing things this kind of tech could do, but think about it. It might help us solve some of the world's biggest challenges, from medical to financial. This type of AI could even come up with brand new scientific discoveries. Think of awesome ways to run our economies or create entirely new ways of leading communities. It's hard to tell when this kind of tech will be available. Many experts are asking themselves the same question, but most agree we're probably not seeing it pop up in the next 10 years. In the meantime, there are a lot of sci-fi movies out there exploring this idea, just in case you're curious. If AI ever reaches its final form, it will become something called singularity. In this potential future, computers will become smarter than us. They'll be so capable that they might upgrade themselves instantaneously. So much so that we won't be able to keep up with them anymore. This idea is still out of reach for now, but with all the cool new AI stuff going on these days, people think the singularity will surely happen. Some specialists have even guessed that by 2045, AI singularity will become part of our world. Hopefully, the people making these AIs will sneak in some safety features along the way. There are a lot of other things to consider. For instance, if AI machines ever become this smart, could we put the brakes on them? Opinions are mixed here too. Big companies want to be part of this AI evolution. No one wants to be left behind. National authorities also want to be leading the way when it comes to artificial intelligence. So even if everyone agrees there are dangerous things to consider, AI is a big deal these days. So pausing all these projects isn't a popular idea. Some have suggested having an off switch for each type of AI. Just in case things get wild, we could hit the button and shut things down. We can't be sure the AI will like that plan. It might become so intelligent that it could find a way to dodge the switch. Let's stay positive though. With the help of different types of AI, we saw magic in mundane tasks like real-time language translations. Everyday objects like watches and fridges got smarter, predicting our needs. Teams of robots working in unison began sprouting everywhere, tackling everything from easy cleanups to sophisticated repairs and even surgeries. AI started stepping into creative arenas too, brainstorming designs for shoes, gadgets, and even gourmet recipes. We used to see self-driving cars only in movies. They now moved from sci-fi pages to our streets. It's time not just to marvel, but to also actively participate. We humans have the pen and the paint. Let's ensure the AI portrait we paint is vibrant and serves all of humanity.
Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty BAM! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases! Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though. And it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
So, if you were to write a sci-fi novel, would you depict robots as enemies of humanity or friends? Or is it even possible to befriend robots? Well, ask Will Robinson. Meanwhile, I'm here to answer all your questions surrounding what our relationship with them will look like in the future. Let's take it all the way back from the importance that having friends plays in our lives and why, as human beings, we definitely need friendship. As of today, it's been proven again and again that romantic relationships improve our health and even help us live longer. And despite the fact that historically they've been treated as less valuable than romantic and family relationships, now we know the same goes for friendships. Part of this is actually due to the overlaps between mental and physical health. That is, if you're being socially active, it's most likely you're being physically active as well. But it also has a lot to do with the brain. For instance, several studies that have used functional magnetic resonance imaging to study patterns of brain activity show that interaction with friends leads to heightened activity in the striatum, which is a region involved in reward. And in one study, researchers found that when participants were given the opportunity to share money with a friend or a disliked, neutral, or unfamiliar person, reward regions were most active when they chose their friend. So it's no wonder individuals with a strong sense of connection to their friends tend to have longer and healthier lives. It's as if they're always being rewarded. But to be more specific about what health benefits valuable friendships provide, well, first of all, they put you at a lower risk for hypertension. In addition, they help you sleep better, as well as heal faster. And the more friends you have, the better. Having a wider variety of social relationships may even enhance your ability to ward off a cold. However, when you have to spend time alone and not by choice, your white blood cells change their behavior, which leads to more inflammation and a weakened immune response. On top of all this, friends not only help your physical health, but your mental health as well. According to one research, there's a link between the time you spend with friends and whether the brain later processes rejection as threatening. Those who had spent more time with friends show less sensitivity to social exclusion. Now, where do robots enter the picture? Well, in the future, we may not be restricted to only being friends with living and breathing human beings, or pets even. To be able to explore the idea of human-robot friendship, we must understand the very basics of robotics. Most of you may be familiar with the concept of robots, but it's actually important to define them as a separate entity from other types of machines. You see, unlike other machines, robots interact with the world. Based on their actions, they're able to adapt and make changes to their surroundings as well as respond to the world around them. They can independently sense, reason, plan, and take action, as well as performing tasks autonomously. They can also extend human capabilities and mimic human actions. The field of robotics traditionally centers on creating robots to perform simple or repetitive tasks, as well as tasks with hazardous conditions for humans. Yet, thanks to the development in machine learning and artificial intelligence, there is a measurable increase in human-to-robot interactions. There are some reports which suggest that the number of robots around the world could reach 20 million by 2030. And that can only mean we'll be exposed to more and more robots in our everyday lives. Therefore, all of us will have to interact with them one way or another. Yet again, does all of this really mean we'll be able to bond true friendships with them? And if so, will our robot friends improve our physical and mental health in every way like our human friends do? Or are robots even capable of being friends? As of today, there are quite a few robots that can perform intelligent tasks, such as adjusting how they respond to individuals and organizing themselves without direct human input. Some examples of that include prosthetic arms that can learn from the person who is wearing them and adapt to their needs along the way. Then there are physical therapy robots that coach patients to learn a task by assessing their individual needs and offering them just the right amount of help. There are also what researchers call swarm robots, also known as a large group of robots. After getting a single command, they are able to collaborate with each other and organize on their own to fulfill the task at hand. This makes them perfect for dangerous tasks such as exploring a collapsed building. Instead of a human having to give commands to each individual robot, you send in the team and they coordinate the whole mission themselves. Talk about autonomy and cognition. So, since robots are able to do all that, it's obvious they can make good friends, right? Well, friendship is not all about benefiting from each other. Take Aristotle, for example. He says that true friendship is premised on mutual goodwill, admiration, and shared values. Accordingly, friendship is about a partnership of equals. So, can we achieve that with robots? Because so far, the relationship we have with robots is what Aristotle would call an inferior one. Yet again, even in this state of benefiting from robots, we relate to a robot just like we relate to pets, possessions, and people. Many folks these days always thank ChatGPT for helping them out with stuff. Some people who work on robot ethics believe that what they do, that is, bonding with a robot, is just a waste of emotional energy. That is because these entities can only simulate emotions, and this will always be less rewarding than forming human-to-human bonds. Well, I've already named my robot vacuum cleaner. Sorry, not sorry. And I know I'm not the only one. According to an engineer who worked at a vacuum cleaner robot company, when customers were offered brand new robots to replace their broken ones, they would decline the offer, saying, "No, I want my robot." They didn't want to replace the robot because they'd grown attached to it. The thing is, according to the psychological evidence we have so far, what I and many other people do couldn't be any more normal. Because according to it, as human beings, it is in our nature to extend emotional connections to things that are very different from us. That is, even when we know they are manufactured and pre-programmed. But the question is, do those connections constitute a friendship comparable to those shared by humans? If we try to answer this question based on Aristotle's idea on friendship, the answer would be no. Then again, the ones that can be considered equal are all destined to evolve over time. So instead, let's look at it this way. Robots can be good companions, which can address our urge to feel a social connection. They can provide physical comfort, emotional support, and enjoyable social exchanges. They won't reject or judge you. One might argue that they also won't understand or empathize with you. But the thing is, they don't really need to. Most people talk to their pets, even though these animals don't understand the words. But they still help you feel less lonely at the end of the day, and robots can do exactly that. There are potential risks with human-to-robot friendships, however. If robots can become our friends, they can very well become our enemies too. But not in the way that sci-fi movies depict. Robot friends can turn into a problem if people start neglecting their relationships with other people to spend more time with a machine. And that is exactly already happening with video games and social media. Yet again, we can all agree that robots aren't the ones to blame.